Hello, Scott. Hello, David.
How are you doing, Deepti?
I'm doing great. What's
Hello,
about you?
Deepti. It's very exciting. You will be the youngest host that we've ever had at this program.
Yeah.
I'll be back in a moment.
Okay. Hello, John. You're muted.
Yeah, I guess I'm at a loss for words, you might say. Yeah, that's the best humor.
Hello. We're trying to come up with the very best Carl Sagan quotes. I've got a couple of them.
Well, I think my favorite, maybe one of my favorite quotes of all time was the introduction to his pale blue dot essay. You know, that's it was so inspiring and so true. But it's about 400 words long, so it's a little bit long for a quote. A snappy quote.
I remember it. It's not snappy, but it's profound.
And actually, you know, I do think of that when things are really, I don't know, I won't say bleak, but things are just a real hassle. I start, you know, it's a big universe out there. This is one small part of it. And we're all made of I think he said star stuff, stardust, star stuff.
Yeah, I think you're right. We are made of star stuff. I got to meet Carl a couple of times.
Hmm.
The time that I really got to meet the man was during the impacts of Shoemaker Levy 9 on Jupiter.
Oh, okay.
And he and I got into a rip-roaring argument when I simply made the statement that I thought that Vice President Gore gave a good speech about the comet. And he just lit into me. He said, "How could you say such a thing? How could you even think that the vice president would know the first thing about comets?" And I said, "Well, I don't know. I just thought he gave a good speech." The person that Carl really got along with was my mom, who was a geneticist, and that's one of his big interests. And,
Well, I sort of met him. I was going to say, I sort of met him once, not really officially. I saw him in the hallway in the physics building at the university, and he walked by with some people. That was the closest I got to him.
And did he stop and say, "It's John, I give you a big embrace"? And he said, "I really need you."
No.
That's what it was like.
No, I think I was only 21 years old at the time, so I was pretty shy.
Good morning. Good evening, David.
Good evening. Hi. It is great to see you, Jackie.
And John. Hi, John.
Greetings.
Good evening, Jackie and John.
And there's Scott. I knew he had to be lurking there.
I'm the guy behind the curtain here.
Yeah.
The closest I ever got to Carl Sagan was one time when I was standing about 1 feet in front of the television. And that's about as far as I got.
Yeah.
When I was watching Cosmos. It was an amazing program, though.
He came to Kansas City one time, 30 years ago or something, to talk to a teachers convention here in Kansas City. And I volunteered to work the booth in the big hall for the Planetary Society. And because of that, I got to go backstage and hang out with him before he gave his talk. So that was my one and only time to meet Carl Sagan.
Well, that's pretty good.
But I got a picture with him.
You got a picture with him. That's awesome.
Yep.
That is awesome. Well, you've had lots of great experiences, Jackie. That's great.
I try.
You've done good.
And David there, he's been to Kansas City a few times to speak at various star parties, and he gets to stay in the Jackie Hotel.
Oh, I've heard of that.
He and his lovely wife.
Yeah.
I got a plaque on the door. David slept here.
Oh,
Pretty good.
David had insomnia.
Yeah.
Well, you have people already logging in here, which is really nice. Book Davies is here, Martin Eastburn, Harold Locke. And there'll be more. So
Scott, when you read off the names, I recognize some of the people, not all of them, but some of the names I think, oh yeah, I've seen that around here or there.
oh yeah, yeah. They're regulars, you know, it's
Yeah.
cool. It is cool. I love it.
Who did your graphics on your spinning world there in the global star party?
They're prepared graphics that you can modify, you know,
Ah.
so yeah. But
Cool.
the posters and stuff I make, you know, from scratch. So
Well, Mr. Goss, what are you up to this summer so far?
I,
Well, Mr. Goss, what are you up to this summer so
Yeah,
far? I mean,
I-
this fall. Duh.
well, let me think here. I've been working with one of the state parks on their outreach, and it's just been awarded dark sky park status. So we're trying to get that going. And I don't know. We had a really nice observing session a week ago. In fact, it was one of those nights in which I was bragging to people on how good this particular site was, and we all went out there. And of course, it was cloudy, but after about an hour, cleared up, and so I was proven to be correct, at least on that one. So you know how that goes. You arrange something, and the clouds move in.
Exactly.
Yeah. This time the clouds moved out, so I was lucky on that front there.
We had a private party down at our Pal Observatory last weekend. It was on Friday night, and a storm had gone through, and the sky was clear. And this party was a big family from northern Missouri, various towns, and they were having a really good time, if you catch my drift. But anyway, it was amazing because we limit use to the telescope. Get back to that.
About 2 or 3 times a century, a massive star in our galaxy explodes. The star's core may survive as a neutron star or a black hole, but the rest of it rushes into space as swiftly expanding debris behind a powerful shockwave. As the supernova remnant grows, it sweeps up interstellar gas and gradually decelerates. Yet even thousands of years later, its imprint on the galaxy remains impressive. Exploding stars and their remnants have long been suspected of producing cosmic rays, some of the fastest matter in the universe. Where and how these protons, electrons, and atomic nuclei are boosted to such high speeds has been an enduring mystery. Now, observations of 2 supernova remnants by NASA's Fermi Gamma Ray Space Telescope provide new insights. Because cosmic rays carry electric charge, their direction changes as they travel through magnetic fields. By the time the particles reach us, their paths are completely scrambled. We can't trace them back to their sources. So scientists must locate their origins by indirect means, which is where Fermi comes in. The interaction of high-energy particles with light and ordinary matter can produce gamma rays, the most powerful form of light. Unlike cosmic rays, gamma rays travel to us straight from their sources. In 1949, physicist Enrico Fermi worked out how what he called magnetized clouds could accelerate cosmic rays. Later studies showed that a variant of his method, called Fermi acceleration, worked especially well in supernova remnants. Confined by a magnetic field, high-energy particles move around randomly. Sometimes they cross the shock wave. With each round trip, they gain about 1% of their original energy. After dozens to hundreds of crossings, the particle is moving near the speed of light and is finally able to escape. If the supernova remnant resides near a dense molecular cloud, some of those escaping cosmic rays may strike the gas and produce gamma rays. But electrons and protons make gamma rays in different ways. Cosmic ray electrons do so when they're deflected by passing near the nucleus of an atom. Accelerated protons may collide with an ordinary proton and produce a short-lived particle called a neutral pion. These pions quickly decay into a pair of gamma rays. At their brightest, both types of emission look very similar. Only with sensitive measurements at lower gamma ray energies can scientists determine which process is responsible. Now, Fermi observations have done just that. They conclusively show these supernova remnants are accelerating protons. When they strike protons in nearby molecular clouds, they produce pions, and ultimately, the gamma ray emission Fermi sees. NASA's Fermi has detected gamma rays from many more supernova remnants, but the jury is still out on whether accelerated protons are always responsible and what their maximum energies may be. Nevertheless, the Fermi team has taken a major step, a century after the discovery of cosmic rays, in establishing just where they arise. Something that would satisfy, but certainly not surprise, the original Fermi.
Well, hello, everybody. This is Scott Roberts from the Explore Alliance and Explore Scientific, and it gives me great pleasure to invite you and to the 63rd Global Star Party, and to introduce somebody that has been on our Global Star Parties many times, but she is now the special guest host of this particular one, and it turns out that she is, I guess it is true, she is the youngest special host or host of this event. So she is someone that is fascinated with space exploration, fascinated with astronomy, and has worked very hard in her community to build up awareness of astronomy, including starting an astronomy club in her own high school. And now she has joined the kind of the national astronomy club of her country in Nepal. Her name is Deepti Gautam, and Deepti, it gives me great pleasure to turn this over to you. I love youth getting involved in astronomy. We are a big supporter of that. One indication of that is the National Young Astronomers Award that we do with the Astronomical League. And the Astronomical League is, of course, with us on every Global Star Party. Deepti, thank you for doing this and for suggesting the theme of this Global Star Party, which is Stardust. So I'm going to turn it over to you now, and thanks again.
Thank you, Scott Robert, and I think it's an opportunity for me to be the special guest host and to invite some of my colleagues and some of the teachers around me who have been inspiration for me too. And today we will have some guests from Nepal. and similarly all the guests who are regular in this program. So first of all, I would like to welcome you all in this 63rd Global Star Party. So first of all, we're moving toward the David Levy. He will give the introduction in poetry. I really love his poetry. And so today the floor is yours, David Levy.
Well, thank you very much, Deepti, and congratulations on being the youngest host of the Global Star Party. I'm really,
Thank you so much.
really glad to be a part of this particular Star Party. Today, we're going to go back a few years because Deepti's theme is Stardust, and the person that I know in my lifetime who has had more to say about Stardust than anybody else, with the possible exception of you, Deepti, is Bart Bach. And I first met Bart by reading a book when I was a little boy, probably a lot younger than you are now, Deepti. And it was called The Golden Book of Astronomy. And he had written the introduction to it. And I finally met him when I first arrived in Arizona in 1979. We became good friends. And he often liked to talk about the work that he did with his wife, Priscilla. It is very interesting. It is very interesting to note that he and Priscilla were two of astronomy's greatest astro couples. People that really got to study the stars together. And as the International Astronomical Union once said, it was impossible to separate her accomplishments from his and vice versa. And after Priscilla grew older, she and Bart would go to the Desert Museum quite often, and she always liked to visit the bird enclosure, the aviary. And she said, you know what they really need here is a chair, because, and she looked at Bart and she'd say, what the Lord has forgotten, be padded with cotton. We need a comfortable chair here, so people could sit and watch the magpies and the roadrunners appear in this lovely aviary. After Priscilla passed away in 1975, 4 days after the opening of the Flandreau Planetarium in Tucson, Bart decided to invest in the bench. It will be the Priscilla Bach bench at the aviary. And so my quote today is going to be part of my book that I wrote, The Man Who Sold the Milky Way, a biography of Bart Bach. The bench became a noble retreat for Bart. In the coming years, he visited it frequently, sometimes alone, more often with friends. Another audience with the roadrunners soon took place. Out from the bushes she came, scampering through, sitting on my shoulder. As he watched this roadrunner, Bart's thoughts wandered back to a far-off place and time. A memory of Priscilla, happy and alert as she fed a group of magpies, filled his mind. Slowly the image faded, and he imagined once again the exquisite swirls of the nebula in Carina. Thank you, and back to you, Deepti.
Thank you,
Okay.
David Levy, and really love that poetry. Yeah, moving to Scott Robert.
Okay, I'll be very happy to introduce our other speakers here. We're expecting Dave Eicher to be on. He may be on a little bit later, but we are going to go ahead and introduce John Goss. John is former president of the Astronomical League, someone who's devoted the better part of his adult life to amateur astronomy and educational outreach in astronomy. The last presentation I saw him give was, fantastic observations of and how to determine the heights of mountains and depths of craters on the moon. I thought it was fascinating. John's a great guy, a good friend to everyone, and he's saying no. He is absolutely someone that you have to meet if you get the chance, and you probably will if you go to the next Astronomical League convention, which will be held in person. John, I'm going to go ahead and turn this over to you, and we can do the questions and answers that the League always does for Global Star Party for the door prizes.
Excellent. Thank you, Scott. That was some nice words, and I guess some of them were halfway true. So
All the way through.
Thank you very much. Yeah, I have a few questions and answers to give to everybody here. But before I do, I just wanted to remind everybody that this is last day of summer. And that means for a lot of part of our country, we have some pretty good observing weather coming up. Generally, at least where I live, into September through about November 1st. So if you can get out under the stars over the next 5-6 weeks, go ahead and do so. There's still some great stuff up there. Summer, even though it won't be summer, you can certainly see the summer Milky Way right after sunset. So that's pretty cool, pretty cool. But let me jump into some of these questions I have and answers. Maybe. There we go. Before we start this, we always like to remind people about looking at the sun. Now, none of the questions I have today have, well, I guess one of them kind of does have to do with the sun, but not looking at the sun. But if you do go out and look at the sun, please observe proper observing safety protocols. And basically what that is always use an approved solar filter. If you don't know what you're doing, if this is your first time in doing so, it would be best to have somebody show you, somebody who knows how to do all this stuff, show you how to do it, just to play it safe. If you have the correct filters and you use them correctly, it's perfectly safe, but you got to know how to use it. Answers from last week's Global Star Party. One week ago, there were 3 questions asked, so we'll run through those quickly. Number 1, Astronomy Day happens twice a year. There is one date left in 2021. What date will Astronomy Day happen in 2021? Well, the answer is obviously October 9th, which I think that's gonna be like a crescent moon in the sky, and on that night, that might be one of those nights to go out and do some great observing. How much does the Earth weigh? Now, this one got me. I was kind of shrugging my shoulders when I read this to you. The Earth weighs in at a whopping 13,170 billion trillion pounds, something like that. And here is a video of how that measurement was made. So you might want to look at this on the internet someplace, figure it all out. Hey, that might be a good high school science project. I don't know. We'll see. Question number 3. What is so impressive about the planet PSR J1719 1438b? That's the old 1438b for you people out there. Well, it's the outer layers of the planet were stripped away by a pulsar that it orbits and left behind a remnant that's composed primarily of carbon. Now, if you put a lot of carbon together and under high pressure, you're going to end up with diamonds. So you might have a planet that is very well a diamond that's 5 times larger than Earth. Well, we'll see. We'll see what happens with that. Okay, the correct answers for last week's door prizes. Let me see, we had 5 people: Josh Kovacs, Stargazer Smurf, love that name, Billy Beck, Andrew Corkill, Marco Kembre. So if you've done, if you're one of those 5 people, you're going to be hearing from the Astronomical League about your winning door prize. Thank you for entering, by the way. Now we have a drum roll, please, for this week. Yeah, thank you. That's
actually, I have one. Here we go.
House orchestra right there. I like it. First question. Oh, well, when you do get your answers, be sure to email them to secretary@astroleague.org. You have to email them to this spot to be eligible. Question number 1. The moon always, excuse me, one moment. Okay, the moon always keeps the same side pointed towards the Earth. However, viewers on Earth can see throughout the year about 59% of the moon's surface. This is due to the phenomenon of A, libation, B, vibration, C, libration. Now, I was going to have a couple other entries in there, all added in Bations, but I thought, nah, I better not. This is enough for you. Always a wise guy here. Okay, that's question number 1. Question number 2. Wednesday, that's tomorrow, is the autumnal equinox, when the sun crosses southward across the celestial equator. In what constellation does the sun shine? Now, I did cleverly blank out the constellation name on this chart. So what constellation will the sun be in tomorrow?
Tomorrow.
Yeah, first day of autumn.
Yes.
Well, partial day of autumn. Question number 3. What is the name of the small constellation between the western edge of the Great Square of Pegasus and the Stahl Altair? It represents the shape of a dolphin. I have to be careful with this because this is one of my favorite constellations. I like showing people because not a lot of people know about it, but once they see it, it becomes a friend for life. It's one of those things which you see in the night sky and you finally understand what it is. And it's there every late summer evening, every September, every October for the rest of your life. So it'll be a friend for life. So anyway, that's the third question. Send your 3 answers to secretary@astroleague.org, and maybe you'll be very lucky. One more slide, then I'll be out of your hair for this month. In 1 month from now, we have Astronomical League Live on October 15th, 2021 at 7 p.m. EDT. So be sure to tune in for that. I don't have the details on what's going on, but they will be worked out shortly. So thank you, Scott. Thank you, everybody, for your time on that.
Thank you, John. That's great. John, before you go, let's talk a little bit about the Astronomical League and, kind of the state of the league a little bit and how people can get involved with the league.
Okay, well, that's great. Okay, it's, let me see, I have 18 after the hour right now. Okay, I got about another 30, 40 minutes I can speak.
Yeah, that's right.
Well, I'd say a few things about the league. One thing the league is known for is its quarterly magazine, The Reflector. We have had so many submissions. We've had so many articles sent in, astro images submitted, that we are backlogged. So starting in December, we're increasing our publication by 4 pages.
Oh, wow.
Let's make it a bit more meaty magazine, and hopefully we'll be addressing some of the needs of our members through this. The league is also known for its many observing programs, which we'd like to try to get our members as well as the public out there under the stars, looking at things. These programs help give them some direction in the sky, because so many times you go out on the stars and you just kind of fiddle around thinking, what should I look for now? I'm not sure. Well, these programs will give you a list, show you how to find things. It'll really enhance your enjoyment under the stars. One of the things that Scott would probably love me to talk about would be some of our youth award programs. Sure. We have the National Young Astronomer Award Program, which young people, I think it's age of 18 or 19 and under, can enter this for kind of a research that they've done. I don't really shouldn't use the word research because it makes it sound like you're at some high level university conducting this stuff. But this is investigative stuff that the person has done on their own, written a report and all that. And we've had some pretty impressive people over the past few years. I believe it's in its maybe about almost its 30th year of this. It must be approaching, maybe it's the 28th or 29th, but it's been a number of years, and it's a great thing. The winner receives a pretty nice telescope from Explore Scientific and a bunch of other recognition for their achievements. We also have the Horkheimer Youth Service Awards, which is more along the lines of a young person helping out astronomy in some fashion, such as doing work for their club, doing outreach, writing articles, working on the website, all types of stuff like that. So I think all in all, we have over 10 pathways for a young person to receive an award.
Oh, that's great.
And I'll conclude this by saying one more thing. These kids aren't going to receive any awards if they're not nominated. And it's been my experience that they don't nominate themselves. So somebody in the club or someone interested, a mentor in astronomy, has to nominate them, or it's just not going to happen. And unfortunately, that's kind of the stumbling block sometimes, because I know there are a lot of deserving young people out there who really aren't given consideration because no one nominates them. And as I said, they're not going to nominate themselves. So please go ahead and think about that and look on our website and find out more information if you know of a deserving young person, and really seriously consider nominating that person.
Excellent.
So on that stern remark, I'll turn it
Stern remark. That's right. Don't forget those young people, So I will tell you that people who have been recognized through these awards have gone on to do great things, and it makes a big change in their lives. So, and you don't want to, not give the kid that kind of chance. So I would definitely, if you belong to a club, you see a young person that is doing some amazing stuff, check into it and see if they're worthy of being nominated, and then follow through. So not so hard to do. And I'm curious though, John, does the nominating or the person that's being nominated, do they have to be in a league club, or could this come from any organization? Or private?
That's both yes and no answer. For the National Young Astronomer Award, they don't have to be a league member.
Okay.
They just have to be under the, I think it's the age of 19, and I think they cannot be enrolled in college. So it's high school or younger.
I see.
But the Horkheimer Awards, you have to be a league member for that. So, if you know of somebody, I have one more thing to say about this. The purpose of these awards, I shouldn't say it like this, but the purpose of these awards, it is not to make kids be professional astronomers. Mm-hmm. It is to open their minds to new things in life, open their hearts to the love of science and astronomy. A lot of the winners, some do go into astronomy, but a lot of them don't. But of those that don't, a lot still go into various fields. And so I think no matter what, everybody wins on this. So, please nominate if you know somebody. Thank you, Scott.
Great. Thank you, John. That's awesome. Okay. And I did put up I think I put up the link for the Astronomical League. I did. So if you need to check into them, please do so. And they'll greet you with open arms, so that's awesome. Our next speaker is Adrian Bradley. Adrian's been on. Hello. Hey, Adrian. He's been on, I think, maybe almost a dozen of our events so far. And,
yeah.
Does that sound about right?
Yep. As soon as you took your chance to see what I may have to offer, but it was largely thanks to my good friend David, who said, "Hey, he's got some nightscape pictures that are nice. Let's bring them on." And I've been hooked on it ever since.
Very cool.
So and here's David coming back. So yeah, he wanted me to come on and share my love of the stars, and I had gotten into nightscape photography more so than just deep sky photography, just because I started out with a camera someone gave me, and I said, okay, this is a DSLR. What can I do with this DSLR? And it took off with figuring out how to do Milky Way photography. I like the title you picked, Milky Way Magic. I'll try and stay along not only the We Are Stardust theme, but the Milky Way Magic. And so what I'll do is share some I'll call them magical experiences. So let me start sharing my screen. A couple of things. I know I just sort of took it all over, didn't I, Scott?
Sure.
You're introducing, and I just sort of started going. But
No, that's
let me
cool. That's
find.
cool. But I did want to add that that your nightscape photography is fantastic. I was trained early on as a photographer, and I know someone that I can tell when someone has a good eye. So, and that you have.
I really appreciate that. And I started doing it more for the love of photography, and that's when I found that my images began to take on kind of a look to themselves, and there's more images to come. Starting with what I'm sharing, I'm gonna share a couple of star parties that I'm involved with. I'm a member and actually president of this club, the Great Lakes Association of Astronomy Clubs. This is coming up pretty quickly. We're going to do an online star party, and I'd be remiss if I didn't mention it pretty quickly. GLAC.org, Astronomy at the Beach 2021. One reason I mention it is one of the well-known Southern Hemisphere skies who's going to be coming up later in this global star party. Maxi Falieres has agreed to do some live viewing on Friday. And the others here are mostly local to the Michigan area. And there's an older picture of me from when we did the impact of comets. So this is one place of many online places you can go. There will be some live streaming. Normally it's an in-person event. And this year, like last year, it's an online event. We chose to go with just doing live solar system or live views, as opposed to making it a full online event, because we weren't sure where we're going to go with COVID. So shameless plug. And I know, Jackie, you're on because you're going to share about a star party that's coming up as well. So there are star parties to support, whether you can go there in person or live stream this global star party. We appreciate all of you that are supporting this sharing of the night sky. It's what we have to do until we're fully open. And hopefully, even when we do get past the pandemic, we continue to do a global star party. Almost every day, someone learns about the night sky and then falls in love with it. So Okie-Tex, I'll be going to that. This is just the front page, and I'll just show the front page of it. So the Okie-Tex Star Party is on. There are going to be some precautions for COVID, and you'll click on this if you go to the website to hear about it. But that's coming up in 2 short weeks, actually maybe 1 short week, October 1st through October 9th. So they surround the new moon, which I believe is October 3rd. So those are 2 star parties I'm involved with. And now it's time to share what I call Milky Way magic here. I'll start with a story of traveling to Sequaminan Falls. Here's the end of the story. I'm actually going to share the end of the story right here. I end up with this photo, the daybreak and what's left of the Milky Way hiding behind the trees. This is one of those photos you generally don't see the Milky Way because there's not much of it. A lot of Milky Way photography makes the Milky Way prominent. But I look for subtle ways to display the Milky Way sometimes. So this happens because as I'm heading here, 30 minutes from this daybreak point, this was taken at the moment astronomical twilight started and the sun was close enough to the horizon to start washing out the starlight, and your dark sky becomes blue. So why did I miss it? That was because I stopped alongside the road. I'm in a Bortle 2 zone, and I got out and I looked at the sky. And what I'm showing you is, to me, one of the most magical things about the stardust. Look at all of the stars here, some of the chemicals that we are made of, and look at how the Milky Way looks. What you're seeing here is what you would see if you stopped along this highway and looked at this Bortle 2 sky naked eye. You would see this detail of the Milky Way. And you may see this coat hanger. This is it's a picture, but it closely resembles what the Milky Way looks like in a dark sky of Bortle 2 or darker. So this site blew me away, and I had to take time to just sit there and enjoy it. And of course, I try and take pictures to bring the Milky Way out. And I learned firsthand that when the Milky Way is this visible, that sometimes you overdo it. And my resulting image ended up being, this is one of the images I usually have as a background, where, and this was done with a stock camera. For those that do know about photography and know that a camera can have filters removed so that you can see more of the hydrogen alpha gas that's going on. But if it's dark enough, your stock camera will pick up some of this detail. This is a part of the Milky Way that it takes a really deep Milky Way shot in order to get some of this part of it. In the southern hemisphere, they get the other side of it as well. This is the summer Milky Way that John talked about, and we call it the summer Milky Way because this part of the core and this part of the bulge leading into Cygnus is generally visible sundown in the summer. However, this was in April, this was in the spring, and it was around 3, I'll say between 3 and 4 in the morning. And I'm driving out and I see this. And because I was so enamored with all the detail and getting these photos, I end up missing that same view over in Tequamanon, and I end up with a sun rising on me and the Milky Way fades away. I did stay for sunrise. Now the moon is coming up over here. That's where some of this glowing light is. It's yet twilight's over a Lake Huron, and this is the ISS as it's going to the southeast. And I waited, and at the break, they call it crack of dawn. You've heard that term. But if you've ever wondered what it looks like, this is what it looks like. When you image it, the light from the sun begins to cast that, we'll call it a Dodger blue in the sky. The Milky Way is still visible, but you basically have between 5 and 10 minutes and it gets washed out. The moon is over here if you can see it. So this is there's a bit of a crescent here where the moon is rising over these clouds. This image is, for me, it's one of those images that I consider unique, because a lot of Milky Way photography usually isn't done. There are some good shots out there that are done crack of dawn, but not many. Most of the time you want your Milky Way most of the shots are super bright and they're against something. You have like this shot right here, you have a meteor photobombing the Milky Way, and this is a Bortle 3 sky, and this is where a little bit of a longer exposure gets you more of the Milky Way. So the way that it looks at this sky, you get your typical white river as your sky goes. Your sky is not as dark, so you don't see as much detail with your eyes, but magically when you put the camera on it, you see the detail because your camera can pick it up. So I'll share a couple more images and then turn it back over. This was with a modified camera. It's what I'm using for my background. The modified camera can pick up the detail of the Milky Way, whereas a normal stock camera, when I took this picture with the stock camera, it didn't come out quite as well. And there's a lot of cloud cover here. Magically, I suppose you could say, the Milky Way can be shot through clouds, And that you can get an interesting effect when you do that, as opposed to a clear shot. It can be shot through aurora if it's dark enough. This is the Cygnus region. There is the North American Nebula. And if I'm not mistaken, this was also done with a stock camera. This is a Bortle 3 zone, and aurora was facing north over Lake Huron.
Wow.
You have aurora,
Color.
and you have the North American Nebula, and here's a combination shot. So this is, I always look for ways of combining stellar things with things that you're seeing on Earth. I like this photo. It's a great way to, well, seeing it, you don't see as many colors, but it's still pretty magical to even look at naked eye. And then if you get a good, nice, sharp shot, it's even more magical when it comes out. Same place. This is actually the same place I took it, and there's the lighthouse. Where I took that other photo, I was standing on the other side of this lighthouse, aiming out at the lake. But it gets nice and dark here, so any shot you take here is going to be nice. Let's go back to this Alcona image. Magical when you get two streaks, meteor streaks coming down, and they're parallel to each other. I once missed a shot when Comet Neowise is in the air, and of course it's orbiting, but we could see Comet Neowise from Earth. It was at a certain angle, and I watched a meteor as I'm setting up to image. I watched a meteor fly at the exact same angle past Comet Neowise, a shot that I wish I had taken. It would have been a really cool, you have a meteor and you have the comet at the same angle in the sky. It's when you do any kind of photography, including night photography, there are so many shots that get away, transient things like meteors. And so I'll leave you with two more images. Magically seeing things like the Andromeda Galaxy naked eye when it's dark enough, and then seeing them when you image, you see even more. This little dot right here is actually a galaxy. That's M33, the Triangulum galaxy, or I think there are a couple of galaxies called the Pinwheel. It has the name Pinwheel, so does M101. This to me is also a magical part of imaging night sky. The objects that the camera picks up, including faint meteors here and there. We see a lot more than we may think we see when we're looking up at the night sky. It's on display for us, and it can be a beautiful sight. So there's always more work to do, more ways to try and smooth out my pictures. It's a little blotchy, but this is give you just how large is the Milky Way, how much stardust is actually out there. Here you have this, looking over the lake, and the entire expanse of the Milky Way stretches out over it. So it's not only beautiful to look at the night sky, and you image it, you can learn a lot more about what's going on with the night sky and how magical things are. So here we are, Lake Hudson, a simple, small, if you want to image the Milky Way, one of the best ways to do it is find a dark sky park such as this. And difference with the dark sky park, there may be some light from nearby towns, but the night sky has enough contrast that it's easy to see a whole lot of stars. You'll see we call it the river of milk, and if you image it, you get more detail out of that quote unquote river.
I really
milk.
love the way how the Milky Way sort of fades and then is connected by a
Yes.
cloud that's going horizontal. And then the way that those clouds on the other side are just kind of picking up and, vanishing into darkness. It's so cool.
Yeah, and that's exactly what was happening in real time. And I happened to capture that moment in time with
That's
a quick
magic.
panorama
That's
here.
cool.
So,
Yeah.
so yep. With that, I'll turn it back over to you, Scott. And
right.
Yep. And thank you all for having me on. And I am on Facebook and on Instagram. Feel free to look me up, and if there's questions, let me know. But there you have it. Magic of the Milky Way.
Wonderful. I included a link to your portfolio page on the internet. So if you go to adrianbradley.myportfolio.com, you can just see a lot more of Adrian's great work. So
Thank you.
So thank you very much. We are now ready to introduce Jackie Beucher. Jackie, am I pronouncing your last name correctly? And you're muted. There you go.
Yeah. No, it's Beucher.
Beucher. Okay, there we go. Sorry about that.
It's
Sorry about that.
German.
We've been, friends for a long time too, so I should know this, but I won't forget it now. So Jackie and I met, maybe 10 or 15 years ago, maybe longer than that, probably at an Astronomical League conference. And she's been involved with the Astronomical League for a very long time. I believe you're still involved and still supporting that great organization. But tonight, you're going to be talking about the Heart of America Star Party, which is held in the heart of America. And Jackie can tell you more about it. So,
okay. I don't have a big fancy slideshow to show you, but I do have some pictures I'll show you.
You do have a beautiful shirt on. That constellation shirt is really cool.
Yeah, I had to dress up for tonight. So the Astronomical Society of Kansas City has been around since like 1925, and we have like 750 members, something like that right now. But about, I think it was like 15 or more years ago, we decided we had to have our own dark sky site. We built our club observatory south of Kansas City. We call it Powell Observatory because the Powell family donated the money to build it. It's about 25 miles south of where I live, but even there now, the light pollution is just washing everything out. And it was in a city park of a small town called Lewisburg, but that's where we would all go on the weekends to observe. But it wasn't so hot anymore. So we got looking around and we found 40 acres of land about an hour and a half drive south of us. And it's just over the Missouri line near Butler, Missouri. And that's, the rest of it's a secret unless you're coming. So, and slowly but surely over the time, we added stuff to it. The big thing we brought in first was saving our money for electricity. Then we built a 40 by 60 foot building, a great outhouse, fantabulous outhouse, and then a shower building. And we have we have power grid out in the field, and we can take up to 20 some odd camper hookups, and then we have regular hookups. And anyway, but it's out in the middle of the boondocks, trust me, and it's really dark and it's beautiful there. So we've been having it every year, and it's the weekend of the 7th, 8th, and 9th of October, same as Okie-Tex. So we're going to have some competition. But now let me see if I can share a screen. Which one is it?
There's a green share screen button on the bottom.
I got that, yeah, but I
okay, now, yeah, and then you just pick the little application that you want.
Yeah, I was trying to find, well, I know what I want to do. I'm going to minimize, I'm going to change this view so I can see what I'm doing. And then I can go over here. And now it's on the screen. And now I'll come back over and share it. Can you all see that?
Not yet.
Not yet. Okay.
Yeah, you
Share
have
screen.
to click on the,
Got it.
and then you have to commit to it.
Share.
There you go. You're doing it.
Okay, cool. So this is where this gives you an idea. It was one weekend. It wasn't necessarily a star party weekend, but it's when we come down there and we have this, and we're located over a hill and through the woods, so to speak, so that there's no traffic out there, and it's out in the boonies. So let's see. There's a shot somebody put on the website. That's the view to the west, of course. And there's some people setting up out there. We have in our 40 by 60 foot building, we do a lot of talks in there. We have a kitchen in there, and it's a really nice building, and we have lots of tables and stuff like that. However, this year we're not having anything in that building. Everything is being catered. We're not fixing it on site. We're having, like barbecue brought in and all that stuff. And so all the meals are, let's see, well, we have until the 18th if you want to order meals. What date is today? Well, we missed the date.
That's the 21st.
But you'd have to bring your own food. But anyway, so that's that. And then that's an instance of when good times, when there's no COVID to deal with. And we bring in a lot of good food and have door prizes. And then there's a pretty flower. Oh, I'm going to just play this while I talk. This is a drone movie here. Let's see if I can get it bigger. There we go. So it's just kind of giving you an idea of the countryside. But can you guys hear that music?
If you go back and stop sharing.
All right.
Stop sharing for just a moment.
Stops?
Yeah.
Okay.
Yeah. All right. And then go back and share. And you'll see on the left-hand corner, there's something that says share sound.
Oh, I have to click it?
Yeah, you check that box and then go back and click back in on the...
Well, right now, I don't want to click it, do I?
If you want to share the sound, you do.
Oh.
Yeah.
I don't want to share
and then
the
you go
sound.
back and click your YouTube thing and then share again.
I don't want you guys to hear that.
Oh, okay, well then you're fine. And don't click that and go back to your YouTube.
Okay. All right. There it is.
It's very faint. It must
Okay,
be
that's
coming
good.
from, it's
That's good.
looping back through your audio.
Yeah, it's just noisy.
It's a very friendly star party. I've been to the star party before. It is dark, as Jackie says, and David Levy and I both went to this event together. It was a lot of fun. Actually, not together. He was going to the Linda Hall Library, where he donated his observing logs.
That's correct. Yeah. Well, that's the whole setup right there. So it's not a huge star party, but it's a fun star party.
The charm of it, though.
We have, we're going to have like geocaching for a treasure hunt for the kids. And, let's see, on Friday night, we're going to have a really great speaker, Mr. Scott Roberts himself. He's speaking Friday night at 7 o'clock.
My pleasure. Yeah.
And then on Saturday, our speaker at 7 o'clock is Michael Bakich. You all know Michael, I'm sure. He was the editor of Astronomy Magazine, a senior editor of Astronomy Magazine. He's contributing now, but he's going to be talking about solar.
We have lost your voice here, Jackie.
I was hoping that wasn't me, or maybe hoping it was. It means no one.
I have some
Yeah.
issues on my internet, and I thought I was
You
behind.
know, I wonder if that microphone's audio cut out. I have that same problem with my audio at times. If I touch it right now, you'll lose my audio too. So yeah,
That's it.
yeah, it's as much as I know about computers, I know that they can be haunted sometimes. I'm sorry, everyone out there, computers really are haunted. We didn't want to
Right.
tell you that. But
Right.
Jackie, we can't, yeah, we've lost you. You have an alternative mic. Yeah, I don't.
It happens.
The only thing I can suggest, Jackie, is to unplug your USB mic that you're talking in, plug it back in, and see if it picks up again.
Sometimes I
I've
feel
had
when like Alan Grant in Jurassic Park when he touched the computers.
No, it didn't.
Right.
See if there's something you can select in Zoom, if you can reselect it. Yeah. Yeah, welcome.
I'll pick up where Jackie left off. Okay. She can still hear us. The Heart of America Star Party is, there's a link to it in this posting. And so you'll, I believe I have one here. Yeah, it's the website is ASKC for the Astronomical Society of Kansas City. Okay. .org, and you will find the Heart of America Star Party, which just the letters HOASP is the acronym for it. But you know, you will be welcome at the Star Party. As I mentioned, it's you know, it's a very tidy, very friendly Star Party. They have when I went, they had you know, hot coffee and things out there for the observers. So when you go, you know, it's out in the boondocks, as Jackie said. So you want to go certainly before it gets dark, okay, and get set up. And if you have to leave, you know, they'll tell you where you can park your car, but you're going to have to park your car out of the area and walk in, okay, and then walk out if that's the way that you want to do this. So, but Jackie will be there herself, and I will be there also on the evening of the 8th, starting at 7 o'clock Central, and giving a talk on Zoom. So it'll be a lot of fun. I know some of my friends, including Paul and Kathy, will be there. So it's going to be, you know, it's going to be a great event, as it always is. So Jackie, thank you so much for coming on tonight, and we'll have you on again. And I'll, you know, doing these kinds of things is all about practice. So no problem. Up next, thank you, Jackie. Up next is one of our youngest stars that will be on the Global Star Party tonight. Libby in the Stars is here with us. And Libby, it's been a little while since you've been on. I know you've been busy at school. I know you're planning on creating an astronomy club too. So yeah, so I'm going to turn it over to you, Libby. But Libby's done, gosh, she's done maybe 50 presentations with us, and she's always entertaining, always informative, and always passionate about the stars.
So recently, I know I just started back school again. I know last year I was virtual. And so when I was virtual, I had all this time. And my mom would joke at me and she would say, "Any homework?" And I'd be like, "It's all homework." And so it was like so easy for me to be able to log on. And now I come back to school where we actually have homework and stuff like that. And it takes up more than half my week. So I really just started school again. And I know while I was virtual, I really wanted to start an astronomy club, but I couldn't. And another thing that really happened over the summer was I joined the mountain biking crew, because I just figured I'm one of those kids who just likes going out in nature. You know, astronomy, I used to do rock climbing, now mountain biking. So it's all this stuff. And so I really wanted to start an astronomy club for my school. And so I love going out in nature, like I just said, and I know there's plenty of kids in my area who are like willing to go out and do all these adventures and stuff. And I know there's plenty of areas for us to go and look. I have my own observing area that I found on a dirt road that's kind of in somebody's backyard. And it's kind of on a rock road, and it's gorgeous and it's beautiful. And it's always kind of my place where I go. So
Nice.
I do live in Bentonville, so there is a lot of light pollution, but I do find my way out to some more areas where it's a little bit smaller in Northwest Arkansas. And so I wanted to start this because not only do I want to make a club, like kids club about astronomy, but I want to make it to where, you know, you get to learn the experience of camping, learn how to do mostly astronomy, learn about where to look in the sky for stars and stuff like that. And I thought, I could do a club, and I wanted to do it for my school. And I started to realize, I'd come in the star party and I hear a lot of you guys talk about how you and your old buddies all the way back then would go on like 2 to 3 hour road trips just to look at the stars. And so I was like, yeah, I want to do that. But then I realized that a teacher would be with us 24/7 because we have to have a teacher to sponsor. And there are probably about 3 really big problems with this, which would be trying to find a teacher to sponsor the club. Because I asked my teacher last year and she wasn't too, excited about it. I asked my teacher this year and she was like, we're not really doing any astronomy this year. So it'd be hard to find a teacher. And also it'd be hard to carry a teacher with us 24/7 because, with school, they expect you to go to bed at like exactly 9:30. And, while you're doing astronomy, you stay up till like 2 to 4 a.m. observing. And so, through the school, there's a lot of red tape that just kind of blocks away kind of the fun rules about astronomy, staying up late and looking at the stars and going far places for astronomy. So I would have done it through the school, but I decided another thing is I'd be able to take my meetings elsewhere than the school, because where the school is, it is also very light polluted. And we don't have telescopes at our school. And we don't really talk about astronomy yet in our school. So I decided that I wanted to host the club myself because I've been wanting to do this for such a long time. And the club will be hosted just between me and my whole family, just mostly me because my family's like, you can run the club. So I hope in the future that I'll be able to do it virtually. I know for a month or 2, I want to go ahead and get the physical club started. And then once I'm getting, pretty good with it and know the team members, I'm going to see if I can open it up through Zoom. And another fear I have is getting Zoom bombed. And I don't have anybody to really like look for the people and interview them before they come on the call. So right now I'm just going to kind of get used to the kids around my area in Northwest Arkansas. And then I'm going to bring it to where we will be able to, host it around the world. Because I know Deepti and there's kids all over the state who are my friends at space, kids all over the world who were in my space camp cabins. And they were like, oh my gosh, if you ever start a club, I would love to join. So once I get that going, I would love to join. So currently for right now, the first club meeting I've planned to hold on this Friday at 7 p.m. We still have not figured out yet the area, but we are going to figure out it today or tomorrow, because this is kind of like a last minute thing. I had my telescope out the other night doing some observing, and I was like, I think I should start a club. The meet will be this Friday. So we are still figuring out those details right now, but once I get the details in, I will post on Facebook. I have a Libby in the Stars page if you'd like to check that out. And we plan to host it in all different areas. I know Scott was willing to let me use the showroom as an area for the club to meet. And I have little spot in my neighborhood where it's nice to go. And of course, that little spot that I found to myself on the road. So I really wanted to do that. And another thing I really, really wanted to do was I did the I got a night at the observatory as one of the doorbell prizes for doing a question. And I still haven't done that yet because I've been waiting for a moment to share it with more people because right now we've been in kind of a pickle with the whole world situation. And so I just hope to keep it as a small meeting for right now. And then with Zoom, I can expand it more. And I really wanted to do virtual telescopes because I know before COVID, Scott was a person who introduced me to astronomy, really. His telescope was up at the square. And so I was like, oh, cool, I'm gonna go see it. So I feel like I can get people interested without having to have them physically in person. I know people can because through sharing with virtual telescopes, it'll be nice to be able to use technology like that and show kids like all this technology that goes behind doing astronomy and stuff. So I hope to work with virtual telescopes and I hope soon enough to upgrade some of my telescopes so I can make it virtual or get a camera to look for the lens so they can at least see what we're observing. So once I get that started, I hope to start up around the world. And I also really just wanted to do this to get more kids out in nature because I feel like I know one of the things I think about often is, you know, kids back all the way back then from when adults grew up, you know, everybody wanted toys, records, and stuff like that. And then nowadays, all kids want is like, ooh, I want a PS5, I want a computer, I want an iPad, I want an iPhone. And so for me, usually in my Christmas list, I am always asking for like, ooh, I want a telescope, I want this new mountain biking gear, I want like rock climbing gear. And, you know, I was like, I hope every other kid can, you know, see the good in nature because I spend a lot of time out in nature and I go every single day. I go to a trail and I know on days that I do my practice for mountain biking, there's just sometimes where it's getting a little late and I can see the moon. I just stop and I'm like, wow. I'm like, look at this amazing view. And, you know, it's like, this is something I'd see online. And I'm like, don't even think about that right now because, you know, this is all they had back then, the woods. And it's just so amazing. And it's just so much fun to go out there and actually do stuff. And I see that there's like a lack of kids who actually want to go out in nature. And I know that every single kid has a desire to go to a muddy puddle and dig in it for worms, go to a telescope and look at the sky, study a tree for 2 hours. I'm like, sometimes I just stare at a rock and I'm like, this is so cool. This maybe came off a bigger rock. Maybe this rock has been here since the prehistoric ages. I'm like, so many things go through my mind. I know every kid has that, but you know, every kid's just blocked by the blue screen that they see every single day for multiple hours. And so I hope to hold this for through me right now. And then I know for kids all around the world, I will do that in a month or two for Zoom and stuff like that. So the meeting is this Friday at 7 p.m. I'm still figuring out the details to where I want it. My email is capital L Libby, the capital A astronomer at gmail.com. For any parents, I know for the kids right now who are listening, don't come to me. Make sure your parents have information first before you come to me. And so we'll do, so you can email me there if you would like to come. And I know in a day, I'll probably post the location and the poster on Facebook for the meeting on my page. It'll be this Libby and the Stars, and I'll keep you guys updated about that.
Wonderful. Well, Libby, you can count on Explore Scientific to give you all the support that we can. You know, so I'm really excited for you, and I think
I'm very excited. I'm like, you know,
yeah.
like
take
It's
the
just-
range, just do it, because often the problem of a lot of red tape, especially when you're going through a school and all of their restrictions and all the rest of the stuff that goes on with that kind of thing, can really impede getting in. It'll get in the way of what you want to do. And I'll tell you that most people, including kids, okay, really are not. I mean, that takes the fun out of a lot of this. But I know you can find a safe way to do it. You work with the parents in the way that you already mentioned. I think everything will be fine. So, but you have resources like I think you can believe that will support you and help you get to whatever levels that you want to go to with your club.
Well, thank you, because I've been so excited for this for a while, because for a year I really wanted to do it. And I feel like it's still, COVID is still 100% there. But I feel like now that we found a kind of way to kind of make sure that we space out 6 feet, and, for those who aren't fully vaccinated, to keep their mask on, and, for kids and stuff, and, wipe down the equipment used. And I feel like there's some more rules now that can help us.
Great. Libby, thank you so much.
Thank you for having me on. I'm so excited to do this. So
yeah,
I've been wanting to do it for probably at least a year and a half now. So
right. And you have talked about it during some of your programs, and when we've interacted before, I knew that you wanted to do this. So wonderful. Wonderful. Anything else you want to add before I let you go?
To just want to give one more warning for the kids who do want to come, make sure your parents reach out to us and not just show up, because I do want to make sure I'll be able to know how many kids are coming and stuff like that.
Yep.
Because I don't want to be like, okay, we have 5 kids register and then like 18 of them show up, and I'll be like, well, I put 6 duct tape marks where we can all sit 6 feet apart, and I have to create 18 more. But it's totally
Extra
fine.
duct tape.
I will rather have 18 million kids than 5, as long as we're all good.
Right.
Yeah.
Right.
I would be remiss if I didn't mention, I think it's a pretty important initiative that you're doing, Libby. So I do hope that it's successful, because it would be you and those kids bringing about a much needed change in the way science is viewed. So I wish you the best of luck, and I hope to follow along with how that happens. And you have Colonel Richards as kind of an example of what can happen when you start a star party in your school, and I'd love to see where this goes. So good luck with it. And
I hope sometime that even if I were to co-host a star party, I can have the members of the club join and stuff like that, and we can kind of talk about. And I know one of the people in the star party sent me a whole bunch of sundials, and I'm so very grateful, because now I've just started my club. So I get to be able to share this with all the kids and be like, this is like a sundial, and this is how you use a star map, and this is how you use a Dobsonian telescope, this is how you use a Newtonian. And
yeah, take your time, try and reach the kids where they are, and then pull them up to your level.
yeah,
An overwhelmed child is like an overwhelmed adult. We'll look for that glazed look in the sky like, okay, that's when you know it's time to tone it down, but you'll get there. Just remember to connect with your
kid. It'll be from how to name each planet in its order, to the concept of how mirrors work and rainbows, and the concept of light beams and radiation.
Cool.
All steps on the way.
I think we're listening to a young Isaac Newton here. So Libby, this is going to be awesome, and I know you're going to have a blast doing it. So when you're ready, if there's anything that you need, certainly you can reach out to me. Of course, there's people here that you can reach out to, including I'm sure David Levy, Adrian, Bradley,
Um,
many of us,
um,
would be
I
happy.
have a bunch of books that I have from all my astronomy. I'm like, oh my gosh, I can't wait to share this with my club.
Yeah.
Like, guys, look,
Yeah,
David
yeah.
Levy signed my book.
Awesome.
Yeah, you'll do well. Yeah,
Yep.
you have all the resources. You don't have to do it alone. Just remember, you don't have to do it alone. You've got a lot of resources. Anyone who's been on Global Star Party, I'm sure, including us, would help you out if you reach out to us. So don't be afraid to do that. Burnout is real. So
And hey,
even at your age.
when I get the Zoom
careful.
meeting started, it's 6 plus up. There's no limit, so y'all can join too.
I
maybe
may
we'll
just
get an
do that.
Oscar
I'll
amongst the
join.
kids.
I think
I'll
we all
join your
will. I
club.
think we all will join. So you let us know. We will
Even
become
from the
members.
south,
I'm sure lots of people in our audience will join too.
Uh-huh.
I would be
So
glad
again,
to join it.
y'all
too.
can get me through Facebook, Libby and the Stars, and the email is capital L Libby the and capital A the astronomer at gmail.com. So
Capital
make
L,
sure your parents reach
lowercase
out
g.
first.
Okay.
Well,
I would ask
Libby,
you
if we
to
are
your mom.
parents, we'll just reach out.
Yeah, Libby, why don't
We're
you
already parents.
why don't you text me in the Zoom chat here that email address, and then I can transfer it over to the chat. Okay.
Thank you guys for having me on. I know I have a lot of resources, and I can't wait to get this going because I've been wanting to do this for so long, and it's like finally it's come.
Great. Okay, so up next is we go all the way from where we are here broadcasting out of Arkansas down to Argentina, and with Maxi Falieres. And Maxi is an amazing astrophotographer, really inspiring because Maxi has taken, he's another guy that has taken fairly modest equipment and has done really amazing, mind-blowing kind of astrophotography. And so he is also, someone that's friendly, encouraging, and is also a force in astronomy down in Argentina as well. And I would add to that a force around the world because he's often on Global Star Party where he's interacting with astronomers that are on every corner of the Earth. So Maxi, I'm going to turn it over to you, man.
Thank you, Scott. Good night, everyone. And Libby, I want to say excellent for your work, like you do, and you have too much to work. And the best is that you are very younger, and you have the status to your friends. So that's excellent.
Thank you.
Well, good night, everyone. Tonight, I want to talk about what things happened a couple of days ago. We have for the COVID situation, the cases goes down for lack of us. And a couple of weeks ago, I talked with my teacher in physics that I say he's Armando Santanel. He's the director of the Southern Sky Park here in my city, Chivilcoy. And we've been talking to do some kind of observation to say to the people, okay, let's go back to those observations, to invite people, of course, with careful, be careful with the COVID situation, but with the social distance and everything. But we were talking in what day will be happen, and we have the last Saturday at the evening, almost 5 p.m. We start to grab our equipment and wait to the sun goes down, and then well, for the lack of us, the people will have come. So let me show you my screen. Okay, do you see it?
Yes.
Okay, so
Yep, as usual, we are amazed with the so-
this.
you could stop there and
Blown
everyone
away,
just
the
goes
total
blown
eclipse
away.
image.
Just that's it right there. All right.
Okay, now well, this is the flyer that we made very fast. This is a screen capture of a Sky Portal, and we promoted on Facebook page because this was days that a few days before this, I think it was 1 week before, because we didn't know how the weather it will going to be. Here we are in the transition from the winter to the spring, and we have too much days with rain and too much days very dry. So this Saturday was a little like a little summer from here. It was very hot, and well, when the sun goes down, the temperature goes very well. So this is a very single picture of what the what we're going to see at 29 or 7 p.m. and then well, let me show you. Sorry, where's the park? Well, this is my city, Chivilcoy. Well, this is part of Argentina, and the park is here in the south place of the city. He's in front of a soccer stadium of the city, and you can see is um, designed like the cardinals pole, the south, the north, the west, and the east, and of course other places. And this is a thematic park. I don't know if no. I think this is a few a very old photo. These have some kinds of playground to the young people, to the youngest. So, but relationship with astronomy. Well, this is going to see this part, and this is a place where sometimes we do some observations, a rooftop, but this is like a charcoal stair, and it goes inside of it also, and where they sometimes do the meetings and chats to show everyone. We've been in this place, and let me show you the photos that I took. Well, this is me, the selfie. And this is we put a screen view with a projector. I went with my all my equipment, a notebook, a telescope mount, and also my other Maxi telescope to play in 2 points. For one place do the projection, and the other place see the people, allow to people to see what it looked like to see from the telescope. Also, well, this is my little Mac with the Star Adventure mount. This is a friend of mine, Ruben. He's a little Dobson, and we have some kind of telescope also here in this park, because we expected not too much people, but the expectation was very, very good. Like you see, the youngest was amazing to see the moon maybe for the first time, and also we have the pandemic situation for 1.5 years, and they were very excited. Um, I remember a father that talked to me and say that his son was watching YouTube videos of Saturn, Jupiter, and I think it has maybe 4 or 5 years old. And he said me, but I can see Saturn from here. Yes, of course, I have the telescope that to see it, and it was pointed to there, and it was freaking very very exciting that child, and also his parents. Um, well, he's a part. He's me and Ruben. We were searching Venus because we have almost 40 degrees at the west, but we didn't point at that because, well, maybe at the later I pointed there, but the people has left. And this is a projection of the moon. Well, I, like I say, I went with my all of what I have. Armando allows me to and give me his projector, an Epson, and when the sun goes down, every time the moon goes very very lightning. So, well, this is a Dobsonian handmade from Armando. He did the optics and the, well, I think maybe this the first time that you see a telescope with square, not cylindric. It's very rare, but it's very manually. It's very easy to manually to handle it, and I think this an 8 inches telescope. So, well, this is more at the night. You can see the kids and the parents was.
They're having a lot of fun. I can tell. That's great.
Yes, yes, it was a very good evening and no, I don't evening, no, afternoon. Yes, afternoon and night. And also the parents, they was amazing to see Jupiter with the moons, Saturn with the moons, and of course the moon was the queen of the night, right? And, well, here's a perspective.
Wow,
of
look at that. That's a nice presentation, really. Wonderful.
This was this designed almost half an hour before of this. It was very like, okay, let's put some cables to avoid the people come here and to get resguard of the equipment, but it was very very amazing. But you know, the people and the childhood, the children love more to see with their own eyes, and no, how I can say it.
Rather than
Well,
seeing a picture of it, right? I mean, they
exactly.
want to see it for real.
This screen, they don't see it. Well, they asked me with my telescope, we can see something here. Well, you are seeing here. I say, and then they realized that, but they think that it was a single picture or something, but no, I was projecting this. And when they see through, for example, the Maxi, they they blow their minds really. And also the parents, the I remember some moms that say, can I take pictures of the moon? Of course. It was very with manually, but I help them because it's very, very difficult sometimes. And well, this is this was pointing to Jupiter and Saturn. In this case, this is Jupiter, and we can well, this is very lightning, but at the eyes, with your own eyes, they was able to see the equatorial storms and the colors. It was amazing, and also the moons. And well, this is a very well. You can see it is very light polluted around it because you have neighborhoods, you have the soccer stadium with the reflectors, but to do observation of planets is go fine. To do observation with DSO is very difficult. Depends of the object, right?
Right.
And in this case, you can see I was projecting Saturn, and well, I think it was a very good night. The people were amazed, and well, this is a single
Wow.
a cube. I did this the Sunday, the day
That's very nice, Maxi.
before, after, sorry, with the telescope, and this is passing by through the moon. No, this was the last Thursday, I think, and I was practicing with the camera and taking pictures of the moon and also Venus, Saturn, but I didn't proceed yet. So, well, this is my little presentation, and I can say I hope in the next time will continue, but I can say now we came back, volvimos. So thank you, everyone.
Yeah, Maxi,
And
thank you. It looks like you put on a great urban astronomy event there, and it's important to go where the people are. You know, if you're doing astronomy outreach, this is something that John Dobson, who we did a very special celebration of John Dobson's birthday. But the thing that he always said is you need to go where the people are, you know, and while amateur astronomers love to go to where it's dark and see the vastness of the Milky Way and all the rest of it, especially in the Southern Hemisphere, they've got an incredible view of the Milky Way when you get to a dark site. But equally important is going into urban areas, urban parks, and that kind of thing to share the love of the sky and the knowledge of the sky right there, because a lot of people who live in cities, even small towns, they rarely look up, and with even a modest telescope, you can show them amazing views. And so I like the way that you guys had that kind of presentation. I think it's excellent, and I'm sure you'll keep it up, but it's wonderful that you could share that with us.
well, thank
Well
you.
done. Well done, Maxi. And of course, we're looking forward to presentation this Friday that you agreed to do for us for Astronomy at the Beach. Your pictures show how, regardless of what the situation's going on, whether it be political or sports, something within each of us seems to stop when we look up at the night sky, and that you had a lot of people that came out to see what's going on, and I'm sure there were a lot of very
because
happy
they are
people.
Curious.
Yes.
Yeah.
And that's
we
why
all
you
are.
have to explode and show, well, this is the moon, you are seeing the moon, okay, well, seeing this with this telescope, and whoa.
Yeah, it's we have a phrase where today where there's a lot of the misinformation things are going on, we call it here, let us show you something that's real, and you see it in
Exactly.
their eyes that
Mhm.
this is something they can count on. It's it's something that makes a lot of it makes sense. It's like if they connect to it, they're
You,
seeing
y-
they're seeing
I,
it in detail and connecting to
exactly.
it.
And when I remember when I was showing people the moon and the planets. Also, I have my laser pointer,
Mhm.
and say, okay, well, this is like you see, this is star. No, this is not a star. This is Jupiter. When like you see in this
Mhm.
telescope. Well, the other one is Saturn. It doesn't start, and at the west it's very shiny Venus, and we
Mhm.
call el lucero del alba in Spanish, the light in well, I don't know how to say it. Well, this is it, it doesn't start either. This is Venus, and also we're very low above the horizon. That point that you see, and then people say, yes, we can say, well, that's even a star. That's Mercury. So you're watching four planets and the moon with your own eyes. And this is like we talk sometimes with Pika, to get the perspective of our solar system and our planet neighborhood. So
Mhm.
I and people, whoa, they start to point every single planet and their minds, and they was like a very three-dimensional.
Yeah, it began to make sense. There's a
Mhm.
picture I didn't show. I decided to take a camera that I normally use for my wildlife photography, which I'll show you at some point, Scott. I think I hear you're a wildlife aficionado as well, but I took that camera and just aimed it at Jupiter and Saturn after I focused it on the moon, and I snapped a photo. When you zoom into the photo, the Saturn
Uh-huh.
photo, you see the rings. It's like
Oh,
a
that's cool.
small view from a small telescope of Saturn. It's a handheld picture.
Huh.
A friend of mine, I think, kind of misunderstood it. They were, you need a Barlow, you need this or that. And I said, the idea isn't to get a great picture here. It's the fact that we can see or take pictures of something so far away, and yet we have the ability to see that.
Yeah.
It's pretty amazing. And then you think about the Milky Way behind Maxi and go, that's so far away you'd never reach it in your lifetime, but we can see it every single night,
Mhm.
and we can
Yeah.
see these stars and all of these galaxies allow us to see so far in the and if then you get technical with it, we see so far in the past. It's like they're like time machines up there as well. There's different ways to present it, but it's all amazing. It's we're sitting here on Earth, we're Stardust, and we're able to see that
We are
far out.
we are selling astronomy.
Yes, that is
Hey,
Astronomy
true.
sellers.
Yeah.
we're going to take a break. We're going to take a 10-minute break, and Deepti is going to bring on astronomers from Nepal, from the Nepal Astronomical Society, or NASO as they call it. But before we go, Sentil, who's watching on YouTube, wanted to know what camera you're using, Maxi.
Right now, the ZWO 533 MC Pro. But also, well, for now, I'm not using my Nikon. This is, well, a single Nikon D80 with the regular lens. But I will try to figure out with I got by the comma corrector to see if I can I will have maybe some very good start with the spikes and everything, because the F5 corrector doesn't allow me. So I'm still working on it, and maybe in a couple of weeks ago, in a couple weekends, sorry, maybe I will go to a farm of the friend of my brother, so I can do maybe some shots to Andromeda or well, I don't know. I'm still figuring out what I can take.
You'll make it up as you go along.
I want to
What I
take
always do.
everything that's passing by through me, but no,
Yeah.
I had to learn to do one object per night, but
Yep.
it's very difficult.
Yeah, that's nope. I came to the same conclusion. As long as I've either observed or imaged one thing, I'm happy with that. So if something else doesn't work out, I'm not upset. I'm not throwing my camera around or throwing temper tantrums. I'm okay. I'm okay with what I have, and I'll build on it for the next time.
Always there will be a next time. Yes.
Yes.
Yes, there will. All right, so guys, we're going to take a 10-minute break. So it's time to go get a sandwich, cup of coffee, whatever, stretch your legs, and we'll be back with more with Deepti Gautam and the Nepal Astronomical Society.
Yep. I'll probably be stepping away from the actual Zoom, but I'll be following along on live streams. I'm very interested in seeing the Nepal Society. This ought to be very interesting. And Maxi, we will be talking in a couple days.
Yes. We'll be in touch, and well, I hope that it will be okay. I didn't
think
see
it'll
that.
be fine.
Oh, let's see the weather was going to be the Friday, right?
Yeah. Yeah, I hope
So-
it's not too cloudy Friday.
Well, it changed something. Maybe the 41% of nuvolosity or clouds. Sorry, but let's see what happens. Tomorrow it will going to be a rainy day, but
Okay.
the Thursday and Friday not. It will be like a very warm
Yeah.
day, but maybe the wind helps.
The wind may
and-
be a
and-
problem.
and clean the day. Well, at the night says there will not going to be clouds. Well, I hope so.
Yeah. Okay, well, we'll see. I mean, as you know, like we do every time, as soon as you fire up the computer and your background image comes up with the solar eclipse, that's usually that image. Such a good image. I think it's what I saw through my telescope when I was looking at the total solar eclipse in 2017. Your image captures what I was seeing with the prominences and the moon blocking it and everything. So it's an image I hope to be able to get for myself.
I hope so. I hope.
Yeah, there's a couple ways I may try. I may just handhold it, because then I can look at it. I can just take a quick handhold shot of it and then zoom in that way. That might be all I do. I want to keep it simple. I have a spotting scope as well, and it has a solar filter. So there are some options that I'll be checking
in this
out.
case, it wasn't with the solar filter.
Yeah, that was without one. But
without.
yeah, I can, until moment of totality, I can have the solar filter, and then I can pull the solar filter.
It will be
off.
rusty.
Yeah, and then try not to move it so that it's off track. But so I've got some options to think about. I don't know if I want to bring big equipment, but then again, the bigger the equipment, the better to look. But we'll see.
Maybe the 80 millimeters, the reflector, the apochromatic, maybe with the camera, it will give you a very good, the very good FOV and
Field of view.
Field of view and a perfect center. The eclipse, I think, is a very good option to use a very light equipment.
Yeah, and I can do it with the 600 millimeter lens that I have may work as well. So, all right. Well, I am going to have to turn in. I had to drum up some energy, but I'll be following along online. Excellent presentation. I did note that you all you were sharing eyepieces. Everyone was masked and everyone had a great time. So it's interesting to see the different ways that astronomy clubs are coming back from the pandemic. And I'm encouraged by the way that you all looked like you were basically with the masking so that there was less risk. And if if the people that are vaccinated, I'm sure it helped. But it's encouraging to see attempts to bring back the outdoor person-to-person astronomy. It's we're in the States, some of us are doing it, but others are, some of the groups I'm a part of are still hesitant to do that. So we're all trying to navigate it together. So that was good to see. I was glad to see the people, and the people are still interested. Anything with space, it almost doesn't matter what's going on.
And
They'll come
whatever
out.
you are, it doesn't
Wherever you
matter.
are, they'll come out. Yep, and it's true. Wherever you are, these things are visible all over the world, and you can go out and see them. So excellent. We'll be catching up with you soon. You are on that website, glac.org. They've got you listed as doing the Southern Hemisphere. So Southern Hemisphere live viewing or just images. If it's too windy, the weather, then I think folks will be delighted to see a few of the images you've done of your skies over the years. It'll be just fine. So we have flexibility.
Okay.
Yeah, and I'm going to be doing observation. I observed through clouds. I observed Altair. I observed Sagitta, and I observed the coat hanger. Couldn't see any of it, and it was in a parking lot. But the binoculars I had, I was able to see those. So I'll be doing a lot of that when I go to the star party next week.
Excellent.
So, yep. All righty. I will see you soon, my good friend, and enjoy. I see Libby took off. 2 minutes, and I'll be tuning in on Facebook to watch the rest of it.
Okay, Adrian.
Like Billy's Astro, I see you running on no sleep, up all last night. That's been my whole life. So for Billy's Astro out there, yeah, I know what that is. Yeah, hopefully we'll get some rest at some point. All righty.
Okay, man. Okay,
all
man.
Right, good
Take
night.
care, and we'll be in touch.
Yes.
See you. Nos vemos.
See ya.
Ever since the Big Bang, dark matter's gravity has been drawing the universe together. Once astronomers realized this, they began to wonder what this might mean for the future.
We know the universe is filled with ordinary matter. It's chock full of dark matter. The gravitational tug of all that matter should have sort of slowed the rate at which the universe as a whole continued to expand. Maybe the expansion itself could literally halt, maybe even leading to a reverse Big Bang, the Big Crunch.
Think about the simple act of throwing a ball. Every time I throw the ball up, gravity will slow it down, and at some point will pull it back to Earth. So could this happen to all the stuff in the universe? We know that everything in the universe is flying outward right now, but how long will that last? Could it be like this ball? Slowing down, eventually reversing direction, and returning to where it came from. What would that mean for the future of the universe?
Hello, everybody. This is Scott Roberts here with the Explorer Alliance, and you're watching the 63rd Global Star Party. We're now in the second session of this event, and we have astronomers waiting in the wings here from Nepal with the Nepal Astronomical Society, or NASO as they call it. I'm going to turn this back over to you, Deepti. Are you there?
Hello, Scott. Actually, I'm switched to mobile because I got some problem in laptop, so I'm unable to open up my camera.
Okay.
Okay. Hello, everyone. Again, I'd like to welcome you all in the 63rd Global Star Party, and the theme of the Global Star Party is Stardust. And today we have some guests from Nepal, all the way with me and myself. So first of all, I'd like to introduce all the four members. We have Usman Sharma Katel. He's an undergraduate student, and similarly we have Ansural Sedai. He is higher level graduate student, and similarly Deepti Gautam and Manan Sadwa. And now we will begin from the Usman Sharma Katel. He is undergraduate student, have keen interest in space science and cultural astronomy. And today he is going to talk about the experiment with the slide in the sky in the project called Cubes in Space, which is organized by NASO associated with Cubes in Space. So first to you, Mr. Sarmakadil.
Thank you so much, Deepti, and hello everyone. Namaste. I'm Usman Sharma. I hope my screen is visible.
Yes.
Yes, visible.
Namaste once again. So I'm I'm an undergraduate student and a junior member of Nepal Astronomical Society. And today I'll be talking about my experience of designing a space experiment and flying from NASA. So it flew from NASA Southern Rocket. So let's begin. Ta-da. So in April, Nepal Astronomical Society organized a program called Cube in Space NASA 2021 in the collaboration of Cubes in Space and IEEE Wing. So yeah, the program was from April 10 to May 2020 to 2021. So in the program, there were 55 participants from all over Nepal, and those were the secondary and high school students. So in the among those 55 participants, the motive of the program was to teach them about how a science or experiment is designed to be sent to this space. And the hidden motive was to give those students a hands-on participation on to think about the hustles, like how do scientists and engineers do while designing an experiment, how to think like a scientist and engineer while designing an experiment. So it was an opportunity to give them an hands-on experience. So in those among those 55 participants, those were divided into 15 teams, and at the end of the program, each team was asked to propose an experiment that they would like to float to the space. And each team proposed, and among those 15 proposed experiments, 2 were selected to be flown to the space. One was for sounding rocket, and the other one was for 0% balloon. And fortunately, our team experiment was selected for the sounding rocket. So these are my teammates, and we were team number 15. So the title was our experiment was the effect of ionizing radiation on the size of stars molecules in solution, oblique, and the powder form. So the program was organized during the COVID time. So we didn't have the physical meetup. So we had to come up with the best idea from the simplest thing. And the simplest thing that we had was oblique. So oblique is simply a mixture of cornstarch and water. So that's the simplest thing that anyone has known ever. So we thought, okay, that's the simplest thing that we know right now. And we are in COVID situation. So let's make the best outcome of it. So we went and we did further research, and so let's talk about non-Newtonian fluid. So oblique is a non-Newtonian fluid. So here's a small video. So yeah, the unique thing of any non-Newtonian fluid is that it doesn't act like a normal liquid. So when you just stir up or doesn't apply any force or pressure to it, it just acts like a normal liquid. But when a force is applied to it, it just gets solidifies and acts like a damping substance. So it damps the force or resists the force. So that's the unique feature, and we thought, okay, that's cool, that's really cool. So we could use that in our experiment in space. So we thought, and this space is full of uncertainties. So there are small debris, there are small meteorites that could hit our spacesuits, astronauts, and our missionaries in space. So yeah, oblique damping features could be used in spacesuits and missionaries for the protection. They could also be used in shock absorption in spacecraft machinery. They could help us to strengthen cable by soaking it in oblique or any of the non-Newtonian fluid. And also it could be used in bulletproofing, filling potholes, packaging delicate payload, and also to increase the effectiveness of helmets. And also to develop, the non-Newtonian fluid dynamics is one of the least explored fields in the terms of in the field of scientific data. So this could help the scientists to develop mathematical models and do further research and development in this field. So the main objective of the program was to make students eligible of designing an experiment of their own, or to make them able to think like a real scientist and engineer. So to design any experiment, the first thing you have to need you need is an entity. Entity is a subject that you are going to do your research on. So our one was oblique or cornstarch and the cornstarch powder. So after that, so why you want to do this experiment? So what's the reason that you are doing the experiment? Doing this experiment. The first one could be like, what are the problems in the field of your entity? And what's the real Earth and space-based problem that could be solved by your experiment, or that could be targeted by your experiment? So we have to go through that. We have to think on those specific fields. After that, we have to go for the background research. We have to go for the background research, like what research has been, what experiments has been done till the date regarding the entity or the experiment that we are proposing. So on the basis of all those research, all those brainstorming, now we have a firm base now. And now standing on that base, now we have to hypothesize the outcome of our experiment. So the outcome, our hypothesis was, if 30 ml of oblique in the ratio of 2:1 and 40 grams of cornstarch are exposed to ionizing radiation during their flight in the lower thermosphere, then the size of starch molecules will increase by 10%. So this was our hypothesis. So the whole experiment, the name of the program was Cubes in Space. So there's a cube that would be taken to the space. So our whole experiment has to be fitted inside the cube. But when I first saw the cube, it is that small. You can see in the picture, which is being shown in the screen. So when I first saw that cube, so is the first thing that came across my mind, like, isn't that too small for us? Where we can fit our experiment? Because in high school we were like used to see big laboratories, big instruments for our experiment, and that cube is so small for doing an experiment. So that was the first thought that came across my mind when I saw the image. But later on during the campaign, I got clear. Science and experiment can be done anywhere and can be fitted anywhere. So these were our experimental designs. So these were the diagrams of our experiment of a cube that was sent to the space with the help of NASA's sounding rocket. So after all those hustles, after all those months of plannings and those brainstormings, learning things, unlearning the outdated things, and learning and correcting ourselves, we proposed an experiment. And after the continuous presentation, we got selected, and finally we had a liftoff. So on July 25, 2021, our space experiment was flown to the space with the help of NASA's sounding rocket from NASA's Wallops Flight Facility, and our experiment was flown to the space. So the whole duration of the flight was around 16 minutes. It flew in the suborbital. The duration of the suborbital flight was around 7 to 8 minutes, and the micro and the rocket went through the microgravity for around 2 to 3 minutes. So in the whole 15 minutes, our experiment got exposed to space and the ionizing radiation. So this is my journey of how I turned a dream of designing an experiment and sending it to the space with the help of NASA's rocket. So thank you so much. Thank you so much for listening to me. Thank you so much for getting me on board on this global star party. I'm really grateful to Deepti and Scott Roberts. So thank you so much.
Yeah, thank you so much. That's wonderful. That's wonderful. I had never seen this type of material before, so it makes me want to get some myself to play with. So
it's so unique that the non-Newton fluid features is such unique that when you just when you play with it, it gets liquefied. But when you just exert force on it, it solidifies. So it's so unique. So it's a kind of material that you can play with kids. It's the simplest thing, but we made the best outcome out of it.
Wonderful, wonderful, very cool, very cool. Okay, so Deepti, do you want to bring on the next speaker?
Yeah, first of all, thank you so much, Asan Sharma Katil, for bringing up your presentations, and we really love it. Now moving to the Ansuraj Sedai. He's high school level graduate student. Now he is in gap year, and he is one of the honorable mention of International Olympiad. And similarly, he is busy in college. And he's busy in some of the astronomical programs, and similarly he is involved in asteroid sourcing. So I'd like to hand over this platform to him.
Thank you very much, Deepti. Hello and namaste. I am Ansuraj Sedai. As Deepti mentioned, I am a high school graduate from Nepal, and I am currently in a gap year with the objective of applying to colleges in United States. So I have been doing, like Deepti mentioned earlier, I have been doing some astronomy outreach and different programs related to astronomy, like asteroid source training. I have been participating in that as a mentor. In the past few years, I have been participating in it as a participant, hunting asteroids. So yeah, I have been doing a few activities regarding to astronomy right now. So first of all, thank you very much to Deepti and Scott Roberts for the invitation. Again, it's good to be back here. I was here on the 50th Global Star Party, and I really enjoyed the company at that time, and I was enjoying the presentations of the earlier speakers as well. So yeah, it's good to be back. So today I will be talking about, like, the theme of today is Stardust. So how it relates to life, and more specifically, how the advancement in space technology has contributed to us, to human beings, in day-to-day basis. Um, so first of all, starting off with like how our life is connected with the stars and how we are comprised of stardust. So if we study the different elements and the atoms that are present in our body, we will find that majority of them will also be present on the core of the burning star. Like this was discovered by different techniques from, and it has evolved, and it has been sophisticated over the years. But the primary function, the primary way to do that was spectroscopy. So we take the spectroscopy graph of the stars and compare it with the elements we have discovered until now, and we find out what elements the star is comprised of. And by analyzing it with the same with our human body, we found that the abundant of our uh, elements found in our human body are also in the core of the stars. So like the majority of those elements are found in the central region of the galaxy, but majority the main fewer heavy elements of life building blocks such as oxygen are found on the stars on the outskirts of the galaxy, like our sun. So this is how we are made of the stardust. So let's move on to like how the space science advancements and technology has transformed our society. So there has been many inventions, there have been many inventions that has directly impacted our life, which would have not been possible if it was not for the space. But many people in general think that the investment in space science and technology, uh, sending rockets or space satellite or different type of telescopes on space, is just a waste of time and money. So what they are getting wrong is that uh, different inventions and discoveries that have been made throughout this process of space advancement have directly impacted their own lives. Um, and I will share a few examples about the inventions that has really helped us in day-to-day life. Right. Well, one of the great example will be LED, light emitting diode. So these were first developed as a light source to grow plants in space. So while they release waves of light 10 times brighter than the sun, LED provides high efficiency, high energy efficiency, and virtually no heat. So this has not only resulted in more energy efficient light sources in our homes and facilities, but it has also been discovered that LEDs can activate light sensitive drugs used to treat tumors that, when injected intravenously, can completely destroy cancer cells without causing extensive damage to the surrounding tissue. So like we can see a huge application of the LED in our day-to-day life. So it was first designed to work in space. Like like another example will be the development of the water purification. So first manned space missions were comprised of the filter waters, and NASA modified this water purification technology to put it in the use globally. So now, thanks to NASA, rigs at high risk areas can gain access to advanced water filtration and purification systems, which has resulted in life-saving strides towards human survival on a planetary level. So, likewise, another example can be like we used to send satellites to space, meteorological satellites or ecological satellites, if we can say that. So to to analyze the ecological systems all over the earth. Like we were comparing that, we were analyzing those stuffs by looking at the greenery here on earth. And when they turn yellowish or brownish, we used to think that the plants are on the stress and about to go some major changes. Like that was a efficient technique until sometimes it was too late to protect some of the plants and some of the habitants living near it. So what came up was one of the satellite which was measuring the carbon dioxide emissions from the plants in the space discovered a wavelength that was new to any of that was observed from the sun. So what we found that what the scientists found that the wavelengths were actually emitted by the plants. This phenomena is often known as the chlorophyll fluorescence. So this chlorophyll fluorescence help us to know when the plant is going through a major transformation, like the concentration of oxygen and carbon dioxide level of taking in and out of those elements of those compounds were tracked by this chlorophyll fluorescence. So by this help, by this new technology of chlorophyll fluorescence, we are scientists are able to track different major transformation in ecological systems all around the globe. This helps. This has helped to prevent or avoid to some extent drought in Amazon and savanna areas as well. So likewise, the other major space technology advancement that has helped in us in our day-to-day life basis is a field transmitter. So field transmitter were first created to act as a manageable and effective way to monitor the health of the astronauts. So in theory, the pill-sized gadgets would be swallowed, and they then would track the temperature, blood pressure, and other vital signs of its subject. So this technology has gone several trials, and it has been used as a way to monitor the health of fetuses in the womb. So this has been developed over time to look at the different things going inside the human body as well. So likewise, there are many other as well, like MRI scan. Though the credit doesn't directly go to NASA, but the scanning method has been inspired. The MRI technology has been inspired by the scanning method used by the NASA at first. So this space advancement and technology that has helped us has often been overlooked by different people, and one of the main reason why this is because of the existing myths and superstitions existing in our society. So in context of Nepal, people used to, in this pandemic, when the times are extreme, people are generally seen outside of their home, wearing or not wearing masks and following zero to most to none as safety precautions. But in the time of solar eclipse, you can find no one in the people, literally no one. So the road will be empty. All the people will shut themselves inside the house. They think that the solar eclipse will affect them in some adverse way,
Yeah.
and that it is not good to go out in the solar eclipse. So what we are doing from Nepal Astronomical Society itself is we have been conducting live solar eclipse observation and interaction program in types of the solar eclipse. So to tell people that it is harmful in a way, like it is not good to directly see the sun during the solar eclipse, but it is possible to use solar filters and solar glasses to watch the solar eclipse and observe the phenomena safely. And it does not have a major adverse effect in our lives as well. So likewise, another instant I recall is when it was the time of the conjunction of Jupiter and Saturn. So at that time, people thought that the planets are closing in, some huge disaster is coming up. They used to think that. So at the time also, we at Nepal Astronomical Society had conducted observation programs where we watched Jupiter and Saturn within the one frame of a telescope. So it was really cool to see that. So we have been making aware of people about these activities, that they are not harmful at all to us, by organizing different events and awareness session as well. So likewise, in addition to this, we have been emphasizing awareness about significance of understanding outer space and developments related to it by different programs, or as we like to say, weekly bulletin. We broadcast NASO weekly bulletin, and it consists of different national and international current affairs about the astronomical events and the events happening in our country, inside our country, major developments in this field. and so on. So this has certainly helped us to debunk some of the myths and superstitions related to astronomy in general as well. So likewise, another major activity NASA has been doing is the asteroid search campaign and the asteroid search training. So when the general people think about the asteroid, the first picture that comes to their mind is that the asteroid heading towards the Earth, or it is always harmful. So like it is partially true. Like some of the asteroids are hazardous to Earth as well, but the fear often overtakes the belief they hold. And to address this, Nepal Astronomical Society has been conducting asteroid search campaign to identify near Earth objects and main belt asteroids since a very long time. And like I mentioned earlier, I've been working as a mentor there as well. I was a participant a few years ago. So it has been really fruitful to widespread the importance of astronomy in general public. So we have participants in that campaign from age 7 to age 60 from different countries, primarily from Nepal, but we have been collaborating with different other nations as well to get them in this program. So likewise, so one of the main things, like I mentioned in the last Global Star Party as well, was we have been doing outreach programs in different parts of the country. So before pandemic, it was more easier to do that. But in this time of pandemic, also we are following safety measures, and where it is the best to do those programs, we have been doing some of the programs, and we will be up and running when the situation gets to new and the safer normal as well. So yeah, in conclusion, the general public from our nation, from our community, as well from the different side of the world, are afraid of many things related to space, and they are afraid that the time and effort and energy invested on these the kinds of things are not meaningful at all. But we have different technological evidence and proofs to show that they are not true at all. So we have been doing the activities as much as we can, and from the support of Explore Scientific USA, also we have been doing different programs, and we would like to continue that in the future as well. So thank you very much for having me. Thank you once again to Deepti and Scott Roberts for the invitation. Hope to see you also. Thank you.
Well, you are welcome back anytime, including any of the people that are presenting here. So we love to have people from around the world participating in Global Star Party. You know, it is still amazing to me that people can somehow think that the end of the world is coming because of some sort of astronomical event, you know, like an eclipse or an alignment of the planets or something like that. There's always stories that circulate about that. So, you know, scientific literacy is very important in this world. We have many challenges that we have to overcome as a global community of humans, you know, trying to share resources and make the best of our lives. And so, you know, we're very adaptable. You know, I think that we will find solutions, but one of the things that is very, very important that most amateur astronomers can do is help dispel some of the myths of things that are associated with astronomical events. So I'm glad that you guys are doing that work out there in Nepal, and you know, certainly if there's any way that we can support that, support your work, let us know. But in the meantime, getting the word out is very important, and being on a program like this where anyone can watch it is got to help a little bit. So thank you very much. DT, you want to bring on the next speaker?
Thank you, Mr. Amsira Sedai, for your presentation. Now I'm bringing up the young guest, that is Deepti Gautam. He is 13 years old, and he's also involved in, he's junior member of Nepal Astronomical Society. And he is sourcing asteroid. He is involved in asteroid source campaign too. And especially he explore himself and create a video and upload in YouTube too. and he have keen interest in astronomy, space science. So today he is going to talk about the Stardust in the theme. So giving this Deepin, you can begin.
Hello everyone, and thank you Deepti Gautam Didi and Scott Roberts for inviting me. I'm Deepin Gimire from Nepal and I'm 13 years old. And today I'm going to talk about Stardust. So when a star reaches a certain size, it starts a process called nuclear fusion, which forms heavy elements such as oxygen, carbon, and helium. And this process keeps going on. And we know that there is a balance between gravity, which pushes the star inside, and a pressure, which pushes the star outside from the core. But when the star runs out of fuel, the pressure pushing outwards drops, which makes the star collapse. And the collapse happens so quickly that it generates some kind of shock waves, which makes the star to explode. And due to that explosion, all the heavy elements and hydrogen atoms spread far away in space in the form of stardust. And later that stardust and the helium hydrogen atoms feel the force of gravity, and they come closer and they form another star. And the remaining stardust forms heavenly bodies such as planets, meteors, asteroids, etc. After the formation of star and a sun, and before the formation of planets, the plasma in the sun, or the hydrogen ions, was pushed by the solar winds of the sun at that time. So at that time, it was pushed far away, and the stardust included oxygen in them. So the stardust and then the hydrogen ions combined together and then formed a little amount of water. And the water was carried by the stardust, and the stardust which carried water was later formed into comets and asteroids, and the water was frozen into those comets and asteroids. And in the late heavy bombardment period, the meteors and asteroids came into Earth and collided with Earth. And at that time, scientists believed that water on Earth was brought after the late heavy bombardment period, and other essential elements to form life was brought to Earth after the late heavy bombardment period. So stardust brought all the elements and creates planets, heavenly bodies, etc. So stardust makes life possible. So that's all. Thank you.
That was brilliant. Fantastic, Deepin. Thank you so much for coming on to our program. Have you been involved? How long have you been involved in astronomy so far?
3 years.
3 years. Okay.
Yeah.
That's great. That's great. And do you have a telescope now that you're using, or?
Yes, I have.
Wonderful. Wonderful. That's great. And you belong.
That telescope is of Explore Scientific.
Oh, really?
And I used your tutorial to set it up. That there was a video in YouTube.
Oh, thank you. That's great. That's great. Well, wonderful. I hope that you consider coming back on to the Global Star Party again. So you're always welcome. That's great. Okay. Wonderful. Deepti, you want to introduce your next speaker?
Thank you, Deepin, for your set presentations. Now I'm introducing Miss Manisha Doa. She is the project coordinator of Nepal Astronomical Society and astrophotographer of Nepal. And I'd like to hand over the stage to you, ma'am.
Thank you, Deepti. Hello, everyone. Good morning from Nepal.
Good morning.
Thank you once again. Hi, Scott. So I have been hearing about you from stories, and finally I got to be with you today. So as Deepti mentioned, my name is Manisha Dua. I have been involved with Nepal Astronomical Society since 2013. And then I must say there is no looking back since then. If you are interested in this subject matter, currently I'm pursuing my MPhil in STEM education, although like I have my graduation in physics with astrophysics and plasma physics as my majors. Since I joined Nepal Astronomical Society, we have been dealing with, we are trying to reach the community as a outreach at first, although like we are slowly now moving down to education and research domains as well. We have been doing a lot of programs, and I should say like students like Deepti, Ansuraj, Ocean, and even Deepin, yeah, they have been the part of this journey, and looking at them, I can proudly say like they are our success stories, in fact. So it has been very hard here, I guess like everywhere, but when I have to talk about Nepal, it has been very hard to like go to the community and let people understand what actually science is. And Ansuraj also already mentioned about the taboos and the things like that regarding these eclipses and let's say like even the solar halos and all. Yeah. So I thought I should master myself somehow to like network between, to make this connection between science and community. That's why I felt like STEM education could be one of the door that I can actually move forward with ease, try to understand like what I should do and what I shouldn't do. So this has been very helpful for me after I joined this subject. And I today like I will be sharing about like what I do, what we do, and the challenges, and I will be sharing something about astrophotography. So before I wanted to do everything, you know, like I wanted to go and reach out to the community. I used to say like I want to do research and this and that, everything. Yeah, but later on after I started working, I realized like what my genre actually was. So today I'm very much focused particularly in kids and girls and women in STEM education, in fact, and we are using astronomy as a tool, space science as a tool to go to this group of people. That's why sometimes Suresh, being the chairperson of Nepal Astronomical Society, he used to say like, Mansa, you are getting biased because I'm looking more toward this kids and women section rather than the overall programs that NASO is handling. So we even started Women in Science Award in 2017. After I went to a forum, this high-level forum in Dubai, where we had this woman in space networking and breakfast session, I realized that the importance of women in the sector of science and technology as well. So we started this award. We actually wanted to award women and girls from Nepal in astronomy who were involved in astronomy and space science. But later on, we realized like it would be very narrow, and the number of these women and girls particularly acting in this area were very less. So we open it all to like STEM, and since then we had a very good number, like increasing every year. And once the session is like completes, then we start getting emails like when we are going to open the application for the coming next year. So this has also been one of the success story in case of bringing like what I know, what I'm doing in the field of science and technology STEM in Nepal. So beside that, I love getting engaged with students I already mentioned. So like I'm trying to reach out to community school, because when you like if I keep Ansuraj and some students from a community school who are equally capable, even though I know their ability, we can see the student from community school like unable to cope with student like Ansuras or let's say Dipin, So in that case, I felt like we have to give some sort of equal opportunity to student from this sector as well. Mentioning about community school, the gap between community and institutional private school in Nepal is very big, and even like they are equally capable and like they are good in all regards. They are more like I am unable to do like I cannot cope with these people. Like I'm not of the same standard or same level. That's why like we are trying to introduce this 4C to these students in particular. So I'm also communicating as much as I can with female science teachers, and I am more interested in a school which is led by science female principal, irrespective of their subject. But if they are from science education, science field, that is very easy to me to let them understand, because we share similar interests and we share similar challenges as well. So it has been a challenge to bring astronomy and space science to Nepal, in Nepal community, but even I was cautioned by my family time and often, but now they have understood like what I am up to, and they are supporting me morally. So that is the most rewarding things. And like I used to get more by my friends, even like whenever I used to go for this astrophotography, and sometimes when I was used to get nominated by different international international programs, they were like, oh, you are going time and like different places, you are living a sort of luxury life. So is this what you got like with this astronomy things and all, they are used to mocking me like that. And I stopped talking to some of them because that was really painful at times. But then to some of them who were quite close, I used to tell them like, you have seen me traveling, but have you seen like the struggles that I have to go through to make this place for myself? Yeah. And nowadays, many of my friends, they used to text me saying that I want to make my daughter like you, and that is very rewarding to hear. But still, but I'm used to asking them like, are you sure? Because the path is not going to be very easy. And can you bear if your daughter has to go through the similar sort of mockings and similar sort of painful scenarios that I have gone through, and they are like, yeah, you are carving a path for youngsters like my daughters or like my sisters or something like that. So Deepti has been a very good clear example, like and she is even a provincial coordinator for World Space Nepal for the year 2021, and I'm very much impressed. And like I even sometimes envy like why I wasn't like her when I was of her age, you see. So Deepti, congratulations once again. So talking about astrophotography, this has also been a very hard journey, but like I'm able to capture some of the celestial happening that that I can with whatever is just available. And sometimes Nepali people from my community, they used to ask me some question which I used to think like, what? Well, they are trying to interact me, but actually like they were challenging like, this is not the picture some international photographer takes, you are at a very basic level or something like that. And I'm used to I don't tell them anything, because like they have gadgets powerful than what I have this Canon 600D since 2013, and I'm using the same thing till today. And now it is broken and I have to keep it in the shelf. So like even the photography is like not taking place right at the moment. So the fact is I am trying to do the things with whatever possible resources that I have. So it is something like I need not like compete with anyone, it's better if you are doing things, if you are taking me as an inspiration or a catalyst that could help you realize your dream, but like I have taken some of this landscape astrophotography. That is what I can do at the moment. And some of the pictures of planets, Jupiter, Saturn of course, and Moon, and Marsh, and yeah, this conjunction. And mostly I love taking pictures of meteor shower and meteorites, and I have captured Geminids, Leonids,
Nice.
and quadrantids, and the next one I forgot. That occurs around Leonids. Okay, so these are the pictures that I have taken, and that has been featured in some of the popular social media platforms in Nepal as well. So many of them, they know me as a girl who are a lady who is taking picture of night sky, you know. So people generally, it is hard to let people understand the term astronomy or astrophotography. So if I have to make it clear to them what astrophotography or like what I do, I sometimes used to say like that, I'm the girl who take the picture of night sky. You know, it's not astrophotography, because if I say astrophotography, they will bring out all these manipulated pictures and all, you know, and then like they start like, can you do like this and that and something like that. So even here, sometimes I have to reach out to the people, telling them like we have some ethics in astrophotography as well, because to make their picture look beautiful and quite catchy, like they are manipulating it to this extent that sometimes I feel like crying. Because if they are taking a picture of moon, let's say a full moon, and in order to make it beautiful and like people generally, they are always in the run to let their pictures or like their articles published in paper and something, you know. So like they are like taking like they are actually manipulating picture in such a way that sometimes it feels like they like I can understand, you know, the position of my places. Even though the moon goes from east to west, they are taking the picture of the moon completely in the north and in the south, which is actually totally wrong. So it is still like a long way to go to let people know understand the ethics that it holds. Even like talking about if they are taking the picture of Milky Way, it is completely white or completely washed out. The exposure is too high, and the color they put is you know, too extreme, that it feels like something like there is something in the sky which has to be visible with the naked eye from whatever location we are in. So similarly, like in case of like this pink moon, blue moon, or strawberry moon, you know, they just fill the moon with the color, and like they make it pink, they make it red, or they make it blue, you know? So people, they are generally instead of like getting to the depth of something, they are just trying to be famous with the surface, with the word they hear, and they try to relate the things which actually doesn't happen. So this is actually the condition of youth, like while dealing with the youth, you know. And if you ask them to like you have to improve this and this is wrong, and they try to like argue with us. So, you know, but I hope in time they will understand. So if the condition of youth is like that, anyone can actually relate like how hard it is for us to let people, especially the older generation, to understand help them to remove all these superstitions and these taboos from their heart and mind. So like we are working in this field. It has been hard, but I know like this is not impossible, because now many people understand meteor shower, and it's good to see like so many young people with gadgets. They are into like taking pictures and making astronomy accessible to everyone. So thank you.
Wonderful, wonderful. You know, the hardships that you're experiencing, you know, I mean, it's very tough to hear that, and to you know that that there is this struggle, but it's inspiring that you are continuing on, and you know, because you know what's right, and you know, and you're doing the hard work that it takes to bring up your community. And so I think it's wonderful. And I hope that soon you're better recognized for the work that you're doing. Certainly, the more presentations that you can give that are kind of on a more global awareness type of avenue will help. But there are still those that fight against all logic and
Yeah.
and will hold on to the old notions of what they might have heard, the myths and these kinds of things. So I think that we all have to respect the culture, and we all have to respect ideas that people have long held. But if we want to understand nature and ultimately understand more about ourselves, science is really the main path that we have now. The way that we use science to increase our awareness of nature and how that science can benefit us in the long term. So wonderful. Thank you very much for that presentation.
Thank you.
And Deepti, do you also have a special presentation yourself?
Yeah, I haven't prepared a presentation, but I have some quotes about the Stardust, and I have prepared a poem related to I Talk to the Moon, in the topic of I Talk to the Moon.
Okay.
And I have got a very beautiful poem in the internet about the Stardust, and I'll try to be. First of all, I'll start by the scientist Carl Sagan say many times that we are star stuff from the nitrogen in our DNA and the calcium in our teeth and the iron in our blood. It's a great human interest story that we are now able to map the evidence to all the major elements found in the human body and across hundreds of thousands of stars in our Milky Way, and which is said by Jennifer Johnson of the OU State University. This allows us to place constraint on when and where in our galaxy life had the required element to involve. And I have got a poem like it's like you may not believe in magic, but don't you think it is strange? The amount of matters in our universe has never slightly changed. That's all which make your body was once part of something more. And if every breath you ever breathe has seen its all before, there are countless scores of beauty in all the things that you despise. It could once have been shooting star that now makes up your thigh. In atoms of forgotten life who have been since crazed to roam, may now have the great honor to call the croc smile their home. You may not believe in magics, but I thought that you should know the making of your heart were born 14 billion years ago. So next time you feel lonely, when this world make you feel small, just remember that it's a part of you and you are part of us. And we are here, I guess, we are nothing but stardust trying to find its way back to the star. And I'll present my poem, which I've written recently about it. I Talk to the Moon. Just a minute.
I love the poem. That's wonderful. You still with us, Deepti?
I like to share.
Here we go.
File Explorer. Okay, here is. Am I audible?
You're sharing a screen there, but not the PowerPoint.
I'll share my whole screen.
Yeah, it looks like your whole screen.
Okay, am I audible?
There we go. Good. Deepti, is there audio with this presentation?
Yes.
Yeah, you need to unshare and go and click on the left-hand side. There'll be a share system sound or computer sound. So
Oh, sorry for that.
I have
Okay.
forgotten that many times myself. So
Okay. I think now it's okay. Are you listening song?
no.
Okay, I have sent you this video in your messenger. You can play it. It's got Robert.
Sure.
And I have just trying to click the moon.
Oh, you took these images of the moon?
Yeah, by the cell phone and
Oh, very
telescope.
good.
I click the video and try to.
Deepti, you could have chosen any topic for Global Star Party. Why did you pick? What made you pick Stardust?
Okay, I wanted, as I already said you, that I want to relate this global star party by the space in our life. And as you said, how you will relate the space in our life. And I said, we have different mediums, like we are facilitating by all this space materials, like satellite is helping us and all this different stuff. Related to space science and astronomy, and another is the Stardust, which is seems directly linked with us. As it is said, we are all made up of the stardust, which is how our body is formed. Similarly, the star and the others heavenly body around the universe is made. So I chose this theme for today.
Excellent.
And okay, I think I'm not unable to share this sound, so you can share this sound if possible. If you download it.
Okay. So did you send it to me by email?
I've sent it in Messenger. Okay, I will send in email. I think you can download by Messenger if you could possible.
By Messenger? Yeah, we can try that. Sure. By the way, the lineup of speakers that you brought on is fantastic. Really, I think is it's inspiring so many people, young people, working on spreading the word of astronomy. Okay, so let's see. Let's see if I can download this. It's a link, it looks like. Hold on. All right. Let me see if I can share this. And there's audio with this moon video here?
Yes.
All right, we'll give it a shot.
Okay, this is, you can play the poem. I have already sung it. Just next to it.
It's unresponsive. Try one more time. Sometimes getting a file all the way across the world is not as easy as you might think.
Send it to me too. So can I share for her?
Yeah, it doesn't seem to be working for me. Maybe you can send it.
Okay, Austin Salamakashal will try. I think I have sent to him.
Okay.
Let me try.
Good evening, Scott.
Hey, good evening, Simon. How you doing?
I talk to the moon.
So is it audible, the video?
Don't you believe?
Yes.
Look, moon is staring at me. Want to say me something. Wondering, what's that? Awaiting curiously, moon replied. Hey girl, you come out of your home. I asked, you were lost for some day? Where have you been? Moon replied, yes, for a while, for some time. But looks, I'm here with you today, with my bright face and different shape, and some surprise for you. I got excited. Surprise, what's that? Moon replied, I have brought hopes, lots of courage and ultimate energy for you. But you seem sad and frustrated. Why? I replied, I am losing hope within myself. Moon laughed and replied, hey dear, you are beautiful. Just look at me, I have a scar in my face, but all loves me. Why? Everyone is beautiful. Love yourself and believe yourself in what you are, and gain the right to change you, to modify you and be more stronger. Stars were blinking too, and they were saying me, don't you going to talk with us today? I replied, you are my friend. And a whole night talks between us, moon, star and me. May seems strange to other, but I love it. Happy moons and star give me the energy for a smile, and all the astrophile do.
Very nice. Excellent.
Sharing it.
Okay. All right. So we are, if there's anything more you would like to add at this point, Deepti, or anything you'd like to say?
I read this poem. I was sitting in the roof of my house, and I said the moon, and there's similarly moon and star were blinking in the sky, and I thought I was creating something in my mind, and I thought, let's write. And I just come in my room and I started write how I talk to the moon, and how I talk to the moon, and how the moon replies me. And that's all poem about.
I love the poetry you do, and it seems it comes to you quite naturally. So that's wonderful that you're sharing that with us each and every time. And I look forward to the next time that you're on, and anytime you want to do this, Deepti, to bring on people from NASO, they're very welcome. So thank you.
Yeah.
Thank you. Okay, we're going to take another 10-minute break, and then we'll be coming back on with Simon Tang and Dr. Marcello Souza, and more speakers to come. So hang in there with us, and we'll be back.
Whoa. I heard you, but I'm hearing Unica.
Hello, Deepti.
How are you?
I'm fine. It was a great presentation and a nice team you had with you.
To build up a better picture of what Rosetta's flight team is up against, Rosetta's NASA project scientist Dr. Claudia Alexander and her team are recreating the closest thing to a coma on Earth. In this experiment, a miniature comet made of ordinary ice and dust is placed into a vacuum chamber. The temperature is set to minus 190 degrees Fahrenheit, and all the air is sucked out. It's as if this scaled-down comet is in deep space, just like Churyumov-Gerasimenko. The simulation will demonstrate what's happening on the comet's surface.
Okay, so Lauren, are we ready? Ready to go. Okay.
At first, the mini-comet remains mostly dormant. But as the sun's heat intensifies, the comet experiences a sudden and explosive outburst.
Oh, there goes a good one, right there.
Massive jets of gas spew out of its surface in a process called sublimation.
Sublimation is where ice turns directly to gas without having any water involved. So we all know what evaporation is. Sublimation is where we go from a solid to a gas immediately.
When ice heats up in a vacuum, such as in space, it doesn't melt. Instead, it's much more explosive.
And as the sublimating gas comes out, mostly at supersonic speeds, it carries with it the dust particles from the surface. And that is what causes a comet's coma to develop.
OSIRIS's data shows that comet Churyumov-Gerasimenko is in the early stages of forming a coma.
Oh, Scott, we can't hear you.
We can hear you.
There we go.
See? Sign language.
I had a really nice introduction for you, Simon. So,
It's good that they didn't hear it then.
But I want to say it again. I mean, Simon is someone I've known for, gosh, maybe over a decade now. He is a brilliant astrophotographer, a great solar astronomer, and he's been on our program several times. Really blowing our mind on what he can show us on the sun. And he has shared with me deep sky images that he's made. He's also, if you don't know it, he produces videos, which is his profession. He has worked for Woodland Hills Camera and Telescope for a number of years, and has helped astronomers around the world. And I'm glad to have you on, Simon. I'm going to turn it over to you, man.
Okay. So hopefully this was kind of thrown together a little bit, so you guys just have to bear with me.
Your volume's seems to be a little low.
Oh, yeah, I've got my AC running. Let me turn it off, actually. I'll sweat for a minute. That's not too big of a deal. I actually have my C14 outside acclimating right now, so hopefully later on we're going to get to see decent views of Jupiter in a C14.
Great.
It's a big
Great.
scope. All right, so let's share ye old screen. All right, hopefully you guys can see everything.
Yes.
All right, so I'm going to start off with a relatively quick video. So the actual theme of this particular show is obviously called Stardust. And the reason why I'm showing you this video is you're looking at the sun in action. Now, interestingly enough, a lot of people actually think that
the planets and all the other dust and everything else that's in our solar system or in any other solar system is created from supernovas and so forth. But believe it or not, the sun is constantly ejecting out particulate matter. And in this particular case, it's ionized gas, which we can see with all these prominences happening on the sun. Now, these actually travel outwards, which is obviously part of the star. So it's actually stardust drifting out. A lot of people don't realize this, but the solar system is still forming, even though everything has settled down. And as each time the sun ejects out all of this crazy stuff and hydrogen gas, it eventually condenses down somewhere and then reforms over time. Now, you may not think that, you know, a tiny amount of particles or a coronal mass ejection would really create anything big, but in the grand scheme of things, over so many years, it builds up and they get bigger and bigger and bigger. So believe it or not, it's not just the beginnings of the solar system when it forms from a gas cloud. As the sun gives off energy and lets out particles, it too is still forming things in the far reaches of our solar system. Now, I'm going to show you a couple of other pictures as soon as this finishes, because I'm sure pretty much everybody likes to watch this for some weird reason. It's kind of mesmerizing. I thought I had it well timed. Well, I'm going to cut it short, though. So I'm going to show you a couple of pictures now that are from Stardust formation. And a lot of people don't really realize this, but this is a picture of the Eagle Nebula, or M16 as most people would probably know it. Now, this particular image specifically is seen as hydrogen alpha. So we're looking at the hydrogen band, which, if I remember correctly, it's hydrogen at its next level from excitement. I can't remember the exact wordings for it because it's, like I said, I only put this together literally today. But as we peer into all of this, these long, big columns of gas and dust are actually from the stars in the surrounding areas. Now, Hubble has a fantastic image in infrared, which I'm not going to show you guys because I'm sure you guys can find that. You've probably all seen it before, of all the dust that is inside of this actual column of gas that you see here. Inside of there are loads and loads of stars being born from this dust. And as it carves itself out, its own little patch, for a lack of a better description, you can imagine it like, you know, somebody laying stake to a piece of land. The star clears everything out and they slowly start to form planets. But as time goes by, the active star in this region still lets off a lot of particulate matter, which is why we're seeing some of the shapes that we have here. So if we look at the very top of this area of the Eagle Nebula, there is so much happening that it's actually streaming down. And there's several animations that have shown that the formation of stars in here are so tightly packed that it's causing so much disturbance that it looks like it's wind blowing that creates these interesting shapes. Oh, somebody's at the door. Who's dinging that? So now I will then move on to the next picture. Now, most of you probably recognize this picture as the infamous Horsehead Nebula. So the story behind all of this area here is it's not actually just one gigantic nebula. It's actually several different nebulas in different positions. In fact, the one that's found here, which is known as the Flame Nebula, is actually closer to us than the actual background nebula, which is here. And needless to say, the Horsehead itself is not part of that nebula, but actually, I believe they call it a Bok globule or some description, which happens to take on the form of or a shape of a horse, hence why we call it the Horsehead Nebula. Now, again, the same principle is happening here, just like you have in the Eagle Nebula, where inside of here are loads of hot little stars forming up and putting out more and more matter out into there. And in, I don't know, a couple of billion years, maybe this will all probably dissipate and there'll be a bunch of planets and all sorts drifting around and spinning about. Which then brings me to the next obvious thing. Planets. Now, planets don't just form out of thin air. They have to form from something. And again, most of these planets that you see here are formed from leftover material from supernovas. So if you look at our solar system, a lot of physicists and scientists theorize that our particular solar system is a fourth generation from supernovas. So in other words, 4 supernovas within our vicinity had to have occurred before our solar system could have actually formed. Now, one of these planets in our solar system, which happens to be the largest, is predominantly made up of hydrogen, which in certain sense, if it was just a little bit larger, it could actually ignite and actually turn into a star. So some people theorize that Jupiter is actually a failed star. If you're wondering what the black dot in the middle is actually the shadow of Io, and you can see it just here. So next, just to give you an idea of what we're dealing with here, how big is big? So we have here the size of Jupiter, and the sun is actually sitting in the background with a sunspot. And if you look at the sunspot very, very carefully and compare it to the size of Earth, you'll notice that it's almost the same size. In fact, it's probably just a slightly bit smaller in the darker areas. But if you look at the outer section of the sunspot, it will easily engulf the entire Earth. Now, just so you know, the red spot on Jupiter has shrunk quite dramatically and is no longer as big as it claims to be. I think previous estimations used to be 4 times the size of Earth, although it now has come down to the size of maybe 1.5, maybe 2 Earths in size. So I'm going to quickly show you an image from today that I took of the sun. As you could see, this sun is always active. In fact, every time you take a picture, by the following day or even in a few hours, everything has actually changed, which just shows how dynamic everything is on the surface of the sun. And of course, over time, all this particulate matter escapes slowly into space to form new objects. And then hopefully one day we will see something very, very cool happen where a big asteroid gets formed and we can watch it plow into the sun. Kind of like what we saw with Jupiter recently with the flash event that happened not so long ago. So I'm just going to show you another photo. In this one, we can see all the prominences and all the actual solar matter that's happening on the actual limb of the sun. And if I remember correctly, this particular situation, there was actually a CME from a class M solar flare. So again, more particulate matter was thrown out into space that would at some point recoalesce. And of course, last but not least, a quick picture of Saturn. I kind of got to this point of the actual talk, and in all honesty, I think I got as far as to this point here. So if anybody has any crazy questions, I will try and answer them. Like I said, I do have the C14 set up outside, which I am waiting for it to cool down because it's quite a large scope. So I have to wait for this thing to acclimate. And once it acclimates, I will move everything outside and we can hopefully get some live views of Jupiter.
I have, Simon, a question for you. Pekka from Sweden, Stockholm. The maximum exposing time for to still get something granulation of sun surface. I heard a minute.
When you say exposure, do you mean one single exposure?
No, filming.
Oh, it kind of depends on how much magnification that you're actually putting in. So I'm going to do the assumption based upon my setup, because obviously it's my setup and I know how it works. So I have a 150 millimeter refractor.
Yeah.
And I'm using a 5x Barlow in this particular case. So one important factor that I'm going to point out is seeing conditions do need to be very, very good. And what I usually do is I do, on average, a 30 millisecond exposure.
Yeah.
And I take 1,000 shots.
1,000, okay.
And the reason why I need to do that in that particular way is I need to try and capture as much data as possible in the shortest time possible.
Yeah.
So the speed of what you capture is also vitally important. In fact, if you take too long to capture
some of the granulation on the surface of the sun, it starts to smear. So when you
Yeah.
go into processing the actual image, it just looks very, very soft, and it appears like it's out of focus almost.
Yeah.
And in actual fact, what's really happened here is the convection cells have changed so much in that short period of time.
Yeah, it's like small worms in the surface. I have a LAND 50 and ZVO ASI 178 mm, and I'm trying to get 1 minute 60 seconds exposures and keeping there right now, but we'll try a little bit longer. But I can see the granulations begins to get onto worms, like small worms on the surface, because the sun's surface changes all the time, the time.
Well, the problem here with solar imaging, and to a certain extent, even planetary imaging, is it's actually all about resolving power. The bigger the scope, and by the way, I'm not telling everybody to go out and buy big, gigantic scopes. That's not what I'm saying.
No.
But the bigger the scope that you have, the higher the resolving power of your telescope. And that really is the ultimate answer to a lot of things. However, with these larger scopes comes the situation where it just becomes impractical. And that's better. Sorry, and seeing conditions become absolutely critical. So depending on where you're located in the world, there are some parts that are better than others. So the closer to the equator you are, the less likely the jet stream is going to get you when it comes down to doing any type of solar imaging or planetary imaging for that matter.
Yeah. Thanks, Simon.
All right, is my audio still really quiet?
It's good for me.
Oh, Scott's gone all quiet too now. Scott, we can't hear you again.
Scott is tuned.
I'm trying to stay muted so that I'm not, none of my sound is overpowering.
Your heartbeat is in the ear.
But yeah, your volume is so low that Zoom is not focusing on you. So
okay, so is it better now? I mean, I've turned it up quite a lot now, so I suppose I can.
Just one more question to Simon.
Becca's volume is about double or triple yours. So.
Oh, really? Hold on 1 second. Audio settings. I can just jack this up. Sorry if I suddenly just boom over the actual thing.
Now there we go.
Second question, Simon. Where should I put the Barlow? Is it before the diagonal or after? Between diagonal and camera?
Oh, I always put it after the diagonal. In other words, you want it as close to the camera as possible.
Yeah.
And it all depends on the type of Barlow too. There is a difference between a Barlow and a telecentric Barlow.
Okay.
So they are two completely different things. Don't get the two confused, should I really say.
Do you mean Teleview or ordinary Barlow?
Well, the Teleview Barlows, you're referring to the Power Mate. Those are basically telecentric Barlows.
Yeah. Are they better than ordinary Barlows?
They're not the same thing. So it actually, it depends on what you want it to do. A telecentric Barlow, the way it changes the light cone is it's supposed to be a parallel line. So in other words, as you pull the camera away from the Barlow, you should not increase any magnification. I mean, there is a small amount, but it shouldn't. Whereas with a regular Barlow, and if you guys out there are buying Barlows, just be aware of this. When you're buying anything that's a 2x or a 3x or so forth and so on, the chances are the Barlow itself, the actual optical attachment at the bottom, is still just a 2x. But as you move away from it, it gives you the magnification becomes a 3 or a 4. However, the distortion gets worse and worse the further away you go. So certain Barlows, like for example, a 5x that are made, they've been made specifically to correct for that curvature, but you have to get the distancing exactly right. Otherwise, you'll get distortion and all sorts, which is why when you buy something like a Barlow, that's a 5x or even a 3x, you'll see that's very, very long. And in fact, Scott, you sell telecentric Barlows as well.
That's right. Yeah, the focal extender is a telecentric, and so you can place it either before the diagonal, after the diagonal, wherever you place it, the magnification is going to be maintained, generally speaking. So,
I read that in ordinary Barlows, the magnification shifts if you like put it before or after.
That's the spacing. So
Yes.
That's what Simon just explained.
Okay.
So as you're moving further away, you're getting greater magnification, but you're getting also greater distortion.
Yeah. Okay. So one summer just for knowing how to use Barlow in solar imaging. One summer for that. Thanks.
Yeah, you have to remember, and this is like more optical engineering or optical science. I wish you did the talk about this stuff because I actually genuinely know this stuff better.
That's good.
Yeah.
Episode.
So if you actually look at the optical design of what a telescope does and how it focuses light to a point, I better do it in front of the camera. So it focuses light to a point. As you put the Barlow in front of it, when it crosses over, it will change it again. So in order to get more magnification, what it does is as it enters in, it will split it across like this, which is why you see it zoomed in. Okay. So that's actually how a Barlow works, is it actually widens the beam even more, if that makes sense to everybody out there.
Absolutely. Yeah.
So whereas a telecentric Barlow doesn't actually widen the beam, it takes that beam from in the inversion, it'll basically, I'm trying to remember if it flips it back around again. It kind of, I think it does. It flips it back around. So that's how it widens the beam. But instead of the actual light going outwards and tapering out, it actually comes out in a straight line. But I got to try and remember, because there, like I said, there are genuine differences to how the Barlows work. One does not actually cross the beam over. It actually widens it. The other one turns it back the other direction, which is why you see the images flip when you use a Barlow sometimes.
Yeah. So teleview is PowerMate is to prefer.
Well, no, any telecentric Barlow is preferred. I'm not going to turn around and say a PowerMate is preferred.
No, but
that's just a brand. Yeah, that's just a brand.
Okay. So looking after telecentric, then I'm good.
Yeah. Scott will sell you one.
Scott will sell me one. Yes.
Yeah. There's a few out there that you can be looking at. I think also Beucher sells one as well.
I haven't seen very many of those, to be honest. Yeah, I don't see those as often. I know Astrophysics had some really good Barlows back in their time. Again, I haven't seen those in a very long time.
I don't think I've ever seen one. Yeah.
Oh, yeah, we've got one drifting around in the store, a 2-inch big, gigantic thing. It will make your 3-inch eyepieces look like,
really? Huh.
Inch and a quarter plossels.
Interesting. You have to send me a picture. I've never seen one before.
Really?
Yeah.
That's a challenge now. Okay.
All right. Well, very cool. Simon, the images you showed of the sun, I those are all your images, but I think a lot of people might have seen those and think, oh, Simon's showing some stuff from NASA. I mean, your images are so high resolution. Is there any basic tips you would give to people that want to improve their solar imaging?
Actually, yes, there is. Sorry if I'm feeling a little distracted at the same time, because I really, really want to show Scott this Barlow. Oh, there it is. All right, hold on 1 second.
You have like a camera in the store right now or something?
Well, we actually do have cameras in the store, but I'm just going to post it to everybody so you can take a look at it. I'm not going to show you guys because it's an obvious plug for telescopes.net. You really want to go see it, you can find it there.
Yeah.
And you could buy it, or you could buy Scott's one. It's up to you.
I can tell you, Simon, that I was on live stream for Swedish Astronomical Society's visit at La Palma, Swedish solar scope. And we saw all the mechanics and all that stuff downstairs and the telescope up there. And your images is quite as their pictures.
Funny. Okay, so transitioning back to what Scott's original question is, which is also part of what you're saying. The only thing I can really suggest to most people, regardless of the type of telescope that they have, if you don't have the money to throw into hydrogen alpha, by all means get into white light. The most important thing that you need to do when doing any type of imaging is you have to really learn how your weather pattern in your local area works. And I cannot stress that enough, because most of the times when people have problems and they email me or they find me on Instagram and ask me these questions, the first thing I always ask them, and I'm not being nosy, is where do you live, and be specific. Because what I actually do is I look at their area or their surrounding areas. I look at if there's mountains, is it flat, how close to the ocean they are, how much of the jet stream runs through. And the reason why I'm doing all of that is I'm looking at what we call seeing conditions. Now, for those people who are out there that are new to this, when I say seeing, I'm talking about atmospheric turbulence and atmospheric stability, not is it dark out there or can I see the stars? That's generally what we refer to as transparency. To me, transparency when I'm doing solar is not actually relevant. In fact, I've shot through smoke before here in California, because there seems to be a fire every 10 minutes. And, you know, there's one burning not too far from me right now. So my skies are very, very hazy, but it doesn't stop me from actually imaging. In fact, let me just share my screen again real fast. This image that I took from this morning was actually taken while the sky was actually still hazy from all of the smoke in the sky. And the only reason why I can tell you that that has any effect is if you look very, very carefully, if you ignore the noise for a second, the image itself is actually softer than some of the images that I've actually gotten previously. And just to give you an example, if I show you this image and zoom up into it, we can actually see that the actual definition of all the spicules and so forth seem way more defined than the other image. And that's all transparency does to you, is it just loses contrast. But your seeing condition for your local area is absolutely critical. That is what gets you that high detail.
They're spectacular.
Sorry, my cat's trying to jump up on me again.
We have a lot of astronomers with cats. You know that?
Hey, man, that's why they call them space cats.
That's why they're called space cats. That's right. Well, wonderful. Simon, thank you for coming on to the program. Is there anything that you would like to add to your, any comments you'd like to add before we transition here?
I don't know. I think you've got access to all the chat and all that stuff, so I don't know if there's any other questions there.
Well, let's see.
Like I said, I do have my C14 outside acclimating, so
okay.
I will be going outside and fighting with the mosquitoes. So hopefully we're going to see some live views. Well, we are going to see some live views of Jupiter. It's just how good is it going to be is the other question.
Right. The general conversation is going on in chat. They're talking about different brands of Barlows or telecentrics and experiences that people have had with them. So, but I think that you taught them something today. So thank you.
I will say one thing about those guys out there buying any type of Barlow, regardless if it's telecentric or not. Don't go for the biggest one you can possibly find. Don't do a 5X and expect miracles from it, because it all depends on what your target is and how much aperture you actually have and the speed of the scope. 5X telecentric Barlows tend to work very, very well with fast optical scopes with relatively short focal lengths. But if you put it into something like a C14, which I've got outside,
right.
It's just like it's useless. It's just this dim looking disc that just shimmers like crazy, and there's just nothing to look at.
Yes, that's right. Okay, well, we will transition to Marcello, and when you get some live images, certainly just knock on the door. Okay, so.
Oh, I can stick around because I'm going to be imaging the planets for as long as I can cope.
Perfect. Okay, wonderful. Thanks again, Simon. That's
All
great.
right. I'm just
All
going
right.
to hide myself.
Okay, all right. So our next speaker is Dr. Marcello Souza, and he is a highly iconic educator in astronomy. He's been doing educational outreach for many, many years. He's a professor of astronomy in Brazil, and I had the pleasure of attending one of his amazing conferences. And but he's now involved, and it always seems like he's involved in a new project. But this one is really an amazing project, a new educational initiative for students in Brazil and maybe beyond. So, Marcello, do you want to tell our audience what you've got cooking here?
Hi, nice to meet you, Scott. Thank you again for the invitation. It is a great pleasure to be here.
Thank you.
Congratulations, Simon, for the presentation. It was fantastic, the image that he showed. And we have many news now. One of them, I will talk a little about them because we have part of them that I can announce today, unfortunately. But I organized here a presentation to show the news that you have here about astronomy popularization and teaching now.
Great.
I will share here the screen. I'll try. I had a problem with my computer. Now I think that everything is working well. Ever the Murphy's Law work, it was working well before the presentation, before the program, and then when I began the program, I had problems. Can you see the screen now?
I know it's starting to share, but here we go.
Okay.
You're good.
I will show some. I have many. Let me see if we work here. Okay. Now here, where we are in Brazil, in Rio de Janeiro state, in the north region of Rio de Janeiro. And now we are participating. We have two groups here in our region that participate in the Global Science Opera. That's the topic this year is ecosystem restoration. And we have two seats here involved that the students will organize a presentation about the light pollution. And we have one that's a state park, but we have a new one that they organize a presentation this week that's about the turtles. That's the influence of the artificial lights that give problems for the turtles because they go in the direction of the artificial lights in the streets, and they are killed by the cars. Then they change the lights in the coast. You can see here, in the seats, and you see the dark part here is the sand here. Here you have the beach. Then the turtles now don't go in the direction of the artificial lights. That is a fantastic project that they are doing here. And we have now the students of the city are studying about light pollution. All the students of the city is a small city, São João da Barra, near us. They are studying about light pollution, and they organize a contest to choose the lyrics for a music to be presented in the Global Science Opera. Here students make the test. One of the students was the winner. Now they have the lyrics, and they are now producing the music. And I have here a short report that will show. Now let me see if we work here. This was a report in Brazilian TV about her poetry. Talking about the turtles when they leave from the eggs and go direction of the ocean, but if you have artificial lights, the turtles go in the direction of the streets. Then they change the lights here. The student has 15 years, and what is fantastic is that in this city, now the students are talking about light pollution. That's something that they didn't learn in schools, and now with the opportunity to participate in the Global Science Shop, they are studying light pollution here.
It's fantastic. I was talking to Ruskin Hartley. He's the executive director of the International Dark Sky Association, and he talked to me quite a long time today about your program.
Wow, fantastic.
Yes.
It's so wonderful. And here is a longer report. I will talk about another thing now, but they are singing now the music. You can't listen. Then here is the Secretary of Education. This time is involving all the seats. There's something fantastic that's happening here. This is the maze. I didn't forget to show the last edition of the Skies Up magazine. That's a fantastic magazine. Here is the page. I will show for a minute. Is it okay, Scott, if I show here?
Oh, please. Oh, yes.
The magazine. Now I try to. I have one problem here. I need to go back to try to go back here. I try to stop. I found it here. Let me see. Okay, I will share now the homepage of the magazine. Yes, here.
There we go.
Yes, and it is easy to find the magazine in the Explore Scientific homepage. And here is trying to share here. But, okay, now yes. Here the article from Dr. David Levy. My internet is not fine.
It's just taking a moment. That's okay.
Okay, now is the article written by Scott Roberts, and you have articles about the Saturn, how to take picture of the planets, about how to use the smartphone to take pictures, have information about the Titan, the biggest moon of Saturn. I don't know why it's not working the page here for me.
It's loading. There we go.
No. It's not working for me. But it is the problem is with my internet today, my computer, I believe. But here is easy.
I've given the audience the link to go and look at the magazine. You can also see past issues of Skies Up magazine as well. But it is a free global astronomy magazine, and very happy to have you check out the articles. The articles are written by astronomers from around the world, and they range from kind of a beginner level all the way up to quite advanced discussions. So I think you'll like it. There are star charts in there from Will Tirian, the famous celestial cartographer Will Tirian, and Marcello with David Levy. They're the editors of this magazine, so they do a fantastic job. We also took the liberty of including astrophotographs from the people who participated in our last astronomy contest, astrophotography contest. Lots of other good information, including information about the International Dark Sky Association. So
I returned to my presentation. I apologize, but didn't work. I tried to show the magazine, but
yeah, it's sometimes difficult. We sometimes run into
I don't know what's happening with my computer today, but my presentation, I think that is okay. We are going to organize 3 more drive-ins of astronomy sessions here in October 1st, October 9, and October 12. We are going in reality really to organize 2 each day in the shopping center. That is something that we are doing. What's happening? That's not going. Okay, now I'll talk about an app that we developed about on how to produce, to build an alematic sundial. That is here in Portuguese is relógio de sol analêmico, is an alematic sundial in English. You have a version in English and in Portuguese. We had a software that allow people to build. We work in schools to build the alematic sundial with this software, because you have here the hour angles in the table, and here you have the distance where people stay up there, and with the fingers, the shadow give the time. For people that don't know, an alematic sundial is a sundial with a human interaction. The dial are the person that stays there with the fingers up, and then the shadow gives the correct time. Here I have a short movie that shows how works our software. The educational software, put the value of the semi major axis, and here the value of local latitude, and then the software generates all the data to build the alematic sundial. Here you can see I'm putting the local latitude. This was our software. We produced many years ago. Now, with the experience with the software, we produced here we have also an index with all the information about this, the alematic sundial, what's an analema, what is a normal, about solstice and equinox, and everything about how to build. And what's important is because it's very cheap to build one in schools. You don't need nothing special to build. You can use only make draws in the floor, or we did this in schools. We asked the students to choose the best draws that we are going to use in the alematic sundial. I think I will show here a part of this experience in schools. Yeah. Here we produce a model because we consider the same latitude here in our region. Then we produce a model that we put in the school, and we draw the sundial.
Very cool.
And here is a very simple with blocks, rocks. Here in one school. And now this was a master student that was producing his final project with the students in this school. Samara, her name. Here the students at this school, and here the draws made by the students.
Oh wow!
They choose.
It's beautiful.
And now we have a sundial, an app for Android. With this app, you have in English and Portuguese. You have the same tools that we have in the software, but now is an app, and you do the same. You have all the information about the sundial. You put latitude, and here I have a short movie that shows how the app works. Then here I'm using the app to show. I choose the English version.
It's in English,
here,
okay, that's great.
Yes. You have all about an alematic sundial here, all the information to understand what is an alema, like a normal, how to build an alematic sundial.
So people can build a sundial in their backyard.
Yes, everybody can build.
Oh, that's cool.
It is very important to have one because
all of you guys that are amateur astronomers should have your own sundial, you know.
Yes, and we are trying to to motivate the schools to build analematic sundials in the schools. And it's important because they can talk about astronomy, about the movement of the sun during the day, during the year, the movement of the earth during the year. It's something that is very important to show to the students in the school. And here I have how to build. We talk about ellipses, how to produce, to build, to make the draw of the analematic sundial, how to use the data that is in the tables that the app produce.
You know, Marcello, so many people, when they go about their daily lives, they don't really think about how the sun works, or, you know, that our planet's flying through space or any of this. You know, they more or less think that the sun is just a light that allows them to see so they can go to work or something, you know. And, you know, what you're teaching the students, I think probably gives them a big change in how they view the world.
Yes, I believe so, because it is something that they can build easily. You know? And every day they can see how change the direction of the shadows in different times of the day, and how that change if you look 1-2 months later, the size of the shadow at the same time, something that's easy to. Then this is the software, the app that we developed. Now we have the support of a guy from India that he have improvements, and soon will be available free for everybody in the Play Store. This is an experience that we did here.
Oh, that's great. That's great.
Let me go. Let me see if you work here. I have something else to show.
Okay.
But for me, it's not to working.
Okay.
It's not change the page. Oh. I don't know. I wait. I will talk about. I will try to stop sharing here. Okay. And if you work, I'll show you. And now we are beginning. We are near to begin the most important project that we have developed. We have the support of the Explore Alliance Mentor Initiative, if
Yes.
I said correct, that we are going to visit schools.
Yes.
We will have a great support. Unfortunately, today I can't say it's international support, but they asked me only to wait more 2-3 days to make the official announcement of the financial support of the project that's international. But I can say about the project that it's so important for us because we are going to visit a lot of schools, almost more than 40 schools, and we involve more than 2,400 students. We are going to talk, visit during 2 days each school.
Wow.
And in the first day, we are going to talk about astronomy with them. We are going to use a different pedagogical system. We are going to use a modern system that is a design thinking process with the students. We are asking them to solve problems associated with the moon exploration, how they imagine to build a trip to the moon and to build a base on the moon for 3 astronauts. They are going to produce this, and we will be looking for new talents in each school. And these talents will receive a financial support, a scholarship.
Wow.
And to work with us in the development of the project. Then this is something that is very important because these young talents will have opportunities to participate actively in the project. Then in each school that we are going to visit, we will be looking out talents, for new talents, and we are going to invite them to participate with us, and the best students will receive a scholarship. Well, this is something that
Wow.
is
Okay.
fantastic for
This
us.
is a great way to sustain this whole program. So that's wonderful.
Yes. And the support of the mentor initiative will be fantastic, because we will be looking for international contacts between groups from United States with the students here in Brazil.
Yes.
That's something that
Wonderful.
will be very important for the students to know what is being done, and also to have the opportunity to talk with researchers, with people that work with education. That's something that will give a different view for them, and new opportunities, because we will develop in the region that we are developing the project. We have many parts of the region that have many economic problems, and we are going to work only with students from public schools that are located far from downtown, 6 cities of our region. Then it will be an opportunity to show for these students, most of them that will work in the farms. This is what they have near them, and we have many talents there that only need an opportunity to know more about science, to find a career, let's say. I don't know if English that's correct. Career, yes.
Yes.
For them, and we hope that most of them will work with astronomy, with astronautics, with STEM. Then something that we are looking for, and will be our biggest project that we ever developed here, mainly because we will be visiting every week 2 schools.
Oh, that's great. That's great. You said you'll in the 1 year time you will visit or impact about 22,400 students. Is that right?
Yes, 2,400 students at least, because
At
this
least.
is yes, because we have to make an estimative how many students, but we believe that we are going to have more students involved, because we developed the project in more than 40 schools. And they will have the opportunity to know more about astronomy, about space exploration. They will know more about also how to develop an app. We are going to show them how to develop an app, and also we are going to produce cartoons about astronomy.
Cartoons. Okay.
Cartoons about astronomy.
Wow, that's cool. That's cool.
I have
Well,
one artist
about a
are
year,
going to involve.
about 2 years ago, your students set up some CubeSats as well.
Yes.
Will that be part of your program?
Yeah. Yes. But it is something that's not directly involved with the project. It's a different project that we will participate. That is Cube in space. That's you that helped us to send the cube in space. Thank you very much, Scott. Because with your support, that was possible to send the experiments to space, and we sent 8 experiments to space.
Wow. Okay. That's very
It is a fly that goes more than 100 kilometers and then return to Earth. It's a ballistic fly from a NASA.
It's a sounding rocket, right?
Yes, a sounding rocket. I forgot where it is, but it's near New York. I don't know where the name of the city that they launched the rockets. And it was the first time Brazil participated in this project, the Cube in Space. And we sent 8 experiments, and you give the support to help us to send this experiment. Thank you very much. And now we will again involve students we will try to send at least one experiment to space developed from these students, because we are going to find the talents, and these talents will be working with us in a headquarter of the project that we have in our city. And in this headquarter, as part of the project, we will have equipments there. We have computers, we have tablets, we have all the equipments that we need, and we have Legos, we have many things, the telescopes, many things. And we, with these students, we will go to make many research projects with them.
Oh, wonderful.
And one of them is this opportunity to send an experiment to space. First, in Cubing in space, that is a wonderful project. And we hope one day we can send in a satellite, a small CubeSat, and maybe an experiment to the International Space Station. But this is a dream for the future. I don't know. But we will be working now. And one thing that now we are talking about here in the region also is the light pollution, because we have 2 cities involved in this project for the Global Science Opera. We will be responsible for this topic in this opera. Then only these 2 groups in Brazil, and we choose the 2 groups because one of them is one city is you have they protecting the turtles. Then they had to change the lights, the artificial lights near the beach, and now they are changing in the other streets. Then it's something that
that's great.
They now you have also the sky protector for the next generation, because they are planning to have astronomy activities there. We will be working with that, with the municipal governments for that. And the other one city is where you have the headquarters of a state park. And it's a big state park. You have forests inside protected, and you don't have artificial lights inside the park. And they are now waiting the answer from the International Dark Sky Association, because they are in the last part of the process to be considered a dark sky park. And it will be the first dark sky park in Latin America.
Wow, I did not know that. Okay.
Yes, the first dark sky park in Latin America, and is the last part of the process. They are waiting. It's a long process that they need to change.
Yes, they take many things into consideration. That's true.
Yes,
it's
and
not
they have.
Easy. I know.
And they have now the commitments of the state government, the municipal government. They signed a document that they now they will not allow artificial lights and the electric energy inside the park. That's something that is very important, because the sky will be protecting the region. And the park is a very big park. Is the size of a big city.
Wow.
In the middle of the state of Rio de Janeiro. The name of the city that you have the headquarters is Santa Maria Madalena. It's a very small city with 10,000 people that live there. It's a small population. And you have more 2 cities involved. And it's the last part of the process. I think that everything work well soon. We have the announcement of the first dark sky part of Latin America.
Congratulations! That's great. That's a huge benefit for Brazil and I think for Latin America in general. So you guys are serving a great example of what can be done. So that's fantastic. And we're very proud to help in any way that we can. The mentor program is part of the Explorer Alliance educational division, and pretty much everything that we do is somehow involved in education, whether it's these programs or some of the trainings that we have given, that kind of thing. So this will be our first arch into Latin America with Mentor. So we're really, we're very pleased that you've chosen us. So that's great.
We just thank you. We just
Yeah,
like to
likewise,
thank you.
likewise.
Thank you
Fantastic.
for all the support and the help. Thank you
Thank you
very
very
much.
much, Marcello. You've been amazing. And I often talk about you as far as, someone that's so inspiring in the astronomical community. So thank you very much for all you do. Yeah.
My pleasure. My pleasure.
Okay. So Simon, do you have something you'd like to show us?
Yeah, I'm sorry if I look like a creepy ghost when I do this. Yes, I actually have Jupiter in my frame or field of view. It took me a
Okay.
second to find it, so let me just share my screen so you can see everything.
Yeah.
Now remember, this is a C14 with a 2x bar
Oh, wow.
load.
Look at that,
So
though.
any movement that I make will make this thing jump up and down. So
Yeah.
I'm trying my best to stay still as much as I can. And then what I'm going to do is I'm going to try and boost the contrast so you guys can see it better.
I have to admit, Simon, this is probably one of the best live views of Jupiter that I've seen.
Yeah, its seeing is really good right now, which is unusual for the evening for me. You can kind of see every now and then details blur in and out. So I'm going to keep still and not talk too much because obviously my voice is making this thing wiggle. So I'm going to stay still.
I think
Oh,
the
that's
trembling
great.
of my fingers is making it wiggle.
And you can just about see, and I'll use my mouse pointer if you can see it. There's a storm here. There's two storms here. There's a band that runs across up at the top here, and this is the red spot right now.
Oh, yeah. The red spot's standing out big time.
Yeah, so for a lot of people probably going, oh, it doesn't look like it's in focus. Believe me, this is in as much focus as I can get it. Just to show you guys, I'm just going to tweak around with the focuser, and you can see it just goes to nothing. And then as I get past it, but there is a spot, and I've done this so many times. So even if it wiggles, I kind of know when it's in focus, believe it or not.
You got a nice optical set. I can see it popping into focus. That's one of the things that is an indicator of how good your optics are, is that when you approach focus and then it just snaps in,
Yeah, and then every
Kind of
now
kind
and
of
then,
mushing through.
well, this is what I was referring to about the seeing conditions. So atmospherically, it's actually relatively calm, which is why every now and then it kind of like just shoots in at you and you suddenly see these cloud band details for a brief moment.
On my wall, Simon, I have a 55-inch monitor, and Jupiter looks about the size of a soccer ball on my wall, so it's huge.
Yeah, I mean, this is a C14, so it is pretty damn big. I will say this, though. I think I might have to tweak my collimation ever so slightly. I don't know if you can see this, Scott. The edge on this side is way sharper than the other side, and it's not because of, where the sun is facing.
Oh, I see. Yeah.
It is a slight I am getting a slight coma. So if I defocus, you'll see it wants to pull to the one side. You see how the top doesn't quite come together?
Yeah.
Yeah,
Simon, does your telescope have have you fixed the mirror or locked the mirror down, or is the focus moving the mirror back and forth?
The focus is moving the mirror back and forth, unfortunately.
Oh, yeah.
So
it's really one of the big problems with Schmidt-Cassegrain designs like that, because you're pushing the mirror on these telescopes from one side, and it makes it tough to keep that. If this is an F10 instrument, you have a F2 primary and a 5-power secondary. Okay, and all the collimation adjustment is made with the secondary mirror, and so that makes it a little bit tough. When I worked at Mead Instruments, my own personal Schmidt-Cassegrain, I put a mirror. I actually opened up the scope and locked the mirror in place, and then I attached a rack and pinion focuser to it. And eventually, Mead looked at my design, my simple design that I made, and created the mirror locking system that they had used on their LX200 line.
Yeah, unfortunately, I
How much
can't.
detail you're getting. It's really beautiful.
Yeah, unfortunately, I can't do that to this scope because it doesn't belong to me. It actually belongs to the store right now. So
I see.
If it is for sale, but I'm not going to tell you how much. But this is the caveat behind this scope. So this will make you laugh, Scott. This is a 1980s C14. And the only
it's nice.
why I know it's a 1980s and not 1970s model is because some of the telltale signs that it had when we actually obtained the scope.
Yeah.
Sorry, its seeing is actually so damn good. I'm just going to start capturing. I don't really mind if it wiggles a bit.
Yeah.
So the dead giveaway was in the 1970s model, they don't come with the deck motor. On this one, it did.
So what mount are you using, Simon?
Say again?
What mount are you using right now?
Oh, this is my EQ8 RH Pro.
Okay, thanks.
Yeah, it's a serious equatorial mount.
Yeah. Is it compatible with the Celestron CGX?
Oh no, it's way bigger than that thing.
It's way bigger.
Yeah, it's 110 pound payload capacity.
Whoa. Okay, then the C14 is like a piece of cake.
Well, yeah, it's got 3 counterweights on it right now, so I wouldn't say it's that much of a piece of cake. But yeah, it's up
but
there.
It's stable. It's stable.
Oh yeah,
well,
you can see the storms up there on that upper belt.
Yeah,
it's getting really good right now. Very nice.
Yeah, that's gonna be a good picture.
Nice. All right, so we've got Cameron Gillis coming up next here. We'll come back to you. Maybe you can show us some stacked images or something, Simon. So but that was beautiful.
Yeah, totally.
Thank you so much, man. Cameron?
All right. Actually, this is a great segue. And Simon, great to see your stuff. Been following you on all your YouTube channels, and that was a beautiful view of Jupiter. And like you say, very challenging in the live. So I actually have a view of Saturn in my very primitive setup. So let me share my screen here. See here. Oops, I'm going to.
Harold Locke says Saturn is at the meridian, getting late, nice hazy skies, and about to get wiped out. There's at 22 degrees in the east. Very pretty right now. Yeah, look at that.
So this is my view of Saturn, and you can actually see. Now it's very mushy because of seeing, of course. In Seattle, it's lower than Simon. Simon is down in LA area, so he has another, 15 degrees latitude on me. So I'm, but you can see Cassini's division. You can see the ring. You can see the shadow cast by you can see the spherical nature, the ring shadow, and also the shadow of the sphere on it. And what's really cool about this image that I'm sharing is the equipment that I'm using is very primitive, very basic, and what we can do now, and the fact that we can share this. So what I'm doing is I have a smartphone. It's a Galaxy flip phone, and gives you pretty good resolution. It allows me to do pro mode. So you can see I've set the ISO to 50, and I can change the exposure duration as well. And then it allows me to zoom in. So right now I have full zoom. So if I go down here, I can zoom in and out. So here's makes a more pleasing view, maybe at 2.7. I'm using a Mac 102, a 4-inch Mac Cassegrain. and it's on an AZ GTI mount, just with battery operated. And I'm sharing this screen through live view using TeamViewer on my phone to be able to view, show you. So actually, this is a better when you don't zoom in as much. It actually shows you a little crisper view. But yeah, so this is Saturn, and if I got it set up correctly, I'm just gonna go to Jupiter now. Let's see here. Go to Jupiter. Zoom it away. Zoom back out. Looks like Jupiter whipped by there, so it's going to hopefully recenter it. Yep, so it got it. And if I zoom in and just do a little bit of recentering here, and I'm doing this all remote, of course.
Cool.
So let's see here. But this is what you can do with outreach. You know, some of the talk about the outreach before. Definitely, there's no substitute to visual, but to be able to do this is really enables everyone to be able to share.
I think the ultimate is a combination. You know.
Yes.
Showing what you can do, sharing it with a bigger audience that's maybe waiting to look in the eyepiece, because not everybody can look at the eyepiece at the same time. You know, in fact, you know, it's really unless you have multiple telescopes, you know, this really expands, you know, your reach. You know, so it's wonderful.
So if I zoom in here, and I'm going to change the exposure.
At least a couple of moons here.
You can see a couple of the moons, yeah, at this exposure level. And if I go a little tighter, you can start to see some of the. Now, definitely, you know, nothing compared to Simon's
that
C14.
view from Simon's mind blowing.
Yeah. A beautiful image, but the fact that you can do this with just a smartphone computer. Whoops, sorry. A little bit slow. Let me just change the optimize speed so I can get the proper zoom here. Yeah, the fact you can do this, you can share it on a screen, and remotely control it is really cool. That, you know, this is within, you know, reach with the modest budget. All you need is. How are we doing?
Norm Hughes, watching on YouTube, says that Europa is the moon that's closest, and the next one out is Io.
Cool. So if I zoom back out here, let's click on this again. So Europe and Io. Io, yeah. And if I go back out, zoom back out. Oops, I zoom in. Oh, wait. Sorry about that. Go back out. Let me just change the speed, because you can optimize. Let me optimize speed so it refreshes the screen better. There we go. So here we go. One time, and now let's change the exposure to a little bit longer so we can see the moons. There you go. So this is exposing. Let's change the ISO. Actually, that's another way to do it. There we go. So you can start to see the moons.
Oh yeah.
All in a row there. So yeah, some of them are pretty far out. But again, it's nice to be able to fiddle around with the exposure, real time, and look at different features. Whether you're looking at the moons, this is great for planets, for live view. And then of course, if you have better equipment, better optics, you can get it. But it also really kind of gives you, you know, the visual experience, because your eyes can do the lucky imaging for you. Now, obviously, you know, you can get the software to do that, and eventually that will be able to do it real time. But it requires a lot of post processing if you went with the videos with current technology. But it's nice to be able to already do the intermediate step here and be able to see, to kind of overcome seeing conditions, just visually, just with your pro settings here. Let me zoom back in here, and there we go. Whoops. And of course, now I'm going to change the quality. You optimize for quality. There we go. So now you can start to see a little bit of the texture and the festoons in the belts, just a little bit in between. So that's Jupiter. And if we zoom back out again, the last thing I wanted to show you guys all live. Let me just get this. Oh, let me turn this off again. Optimize speed. Zoom back out. Oops. And froze. Let's see here. There we go. Zoom back out. And let's go to the moon. And we'll just zip in there. Yeah, and I just did a quick alignment, and it's all go to, which is nice. You just and hopefully the moon, there comes the moon. Pretty good. And now we obviously have to play with some exposure here. There we go. And then let's change the quality. And there you have the moon. And if we can start to zoom in, which is kind of cool. Look at the craters along the edge here. And we can start cruising the moon a little bit. So I can go, oops. Let's go to some of these craters on the edge. Zoom in. Oops. Oh, it looks like it's, there we go. Sorry, it's a little bit slow. There we go. And you can clearly see the atmospheric. I mean, the moon is still quite low for, it's still early for the moon. It was a full moon, so it just rose about an hour ago or so here in the Pacific Northwest. But still, you can see the some pretty good details, even though there's scintillation. Still stays in focus. The moon and the planets, they remain relatively in the same focal distance. But if you switch to deep sky objects between, if you want to do this, if you're doing outreach, you will have to refocus. Obviously, you're looking at stuff far enough away. But the moon and the planets usually you can maintain the same focus. So yeah, so that's my quick tour of live view. So let me stop sharing, or let me stop that, and then quickly switch to Campstronomy. We are kind of switching gears here. We finished off in Cygnus last week, and we just did the Veil Nebula. And so this is my own personal. Let me just move that out of the way. My low quality, but mosaic. It's not Gary by any means, but this is my mosaic of the Veil Nebula complex. Got the Eastern Veil, Pickering's Triangle, and the Western Veil, and that's how we ended up last week in Campstronomy. And now we're going to switch over to continue the survey into Cepheus, actually, Cepheus, and basically we are going to do 22 new images. We've done over 200 of 148 objects, and we're going to do another 14. So we're going to actually just go through all of Cepheus, including this galaxy that's close to the North Celestial Pole by Pulsars. So we're going to check it all out, and yeah, so look forward to having everyone come in and join me on the exploration. So that's all I have for tonight. Thanks.
Okay.
Thanks, Scott.
All right, Cameron, thank you very much, man.
You
Thank
bet.
you.
Hey Scott, I'm just going to show you Jupiter again. It scene just went rock solid.
Awesome.
All right.
Oh,
Look at that. Oh man.
Wow.
Yeah, a little bit better.
Wow.
and it is the red spot.
Okay,
I thought
Simon,
I
this
saw it.
is hands down the best live view I've ever
Yes.
seen of Saturn.
That's awesome.
You know, without my eyeball being at the eyepiece. Okay, I have seen excellent views of Jupiter, but I'm seeing, you can see detail around the red spot, those two dark knots that's up there on that upper band. These are two other storms, I imagine.
Yep,
that's
and then
awesome.
you've got these two bands that are running along here that are coming in and out.
Yeah. That is just super duper. That's incredible.
So I'm the stack just finished. Hold on. Is there somebody else talking after me after this?
Pekka is on, but
oh, okay. I'll just show you guys this real quick because I'm sure you guys are going to be intrigued to see this once it's actually been tidied up. So I just finished stacking one of the frames.
Mm-hmm.
And to be totally honest, Scott, there's a lot of data that I pulled, so this is going to take a very long time for me to do all of it. But just as a quick run, sorry about the noise.
Was that like a jet plane or something?
No, it's a motorcycle.
Motorcycle.
Yeah, hold on. Let me just set these real fast because I don't have my presets on my laptop. So I do apologize to everybody right now.
Oh, this is nice. Semi-real time. This is getting, see, it's getting better, Simon. That's awesome.
Oh, yeah, I haven't even set the wavelets yet. I'm just setting up the.
Oh yeah. But the point is that the workflow is and the processes that you've got are so good now, and with the computing power and your algorithms that you can do this almost semi-real time. So this is good. This is really cool.
Well, unfortunately, my laptop is absolutely screaming at me right now.
I believe it, but it will get better. Don't worry. Yep.
Hopefully, come on. You guys just got a black screen, haven't you?
Yes.
Oh.
I do see. Yeah, there we go.
You know, I had the privilege to look at Jupiter once through the coup-de focus of the Palomar 200-inch telescope, and it looked nowhere near as good as this.
I don't know why this is having such a bad time. Let me just stop the share because it might be the sharing, and as soon as it does it, I'll show it to you. So.
Okay. All right. Well, we'll go to Pekka and you can work on it, and we'll come back to you.
Yep.
So Pekka.
Uh-oh, did we lose him?
He's there. Pekka, are you with us?
While we're waiting for Pekka, I'm going to see if I can see some of those features in my primitive setup here. I think that's really fun when you can have like a Hubble image or Jupiter. I mean, you can see some features, and then you can see it with your own little, setup. That's really cool.
Absolutely. Now, Cameron, have you been invited to other programs to share some of the stuff that you're doing these days, or?
Oh, thanks. Actually, Scott, no, but and I am kind of already. This is good for where I'm at. No, I mean, it's good in many ways, but I also need to kind of manage the amount of time.
Yeah, that you're devoting. I understand.
Yeah. So, but
you have
this
family.
Yeah, exactly, and I'm not
commitments and work commitments. There's Pekka.
Yeah. So, hey, Pekka. But I look forward to in the future. That there will be more involvement.
Pekka, do you want to?
Yeah.
There we go.
You gave me so broad topic, so I don't know where to begin. But anyhow, there was something about the elements. So
Yes.
so I found a little bit text that shows a little bit about the elements. Wait, I can put it there. So this Word document, but anyhow, let's see there.
You know, when I think of you know, the fact that we're made of stardust, I mean, there's so many kind of poetic things. You know, my mind kind of goes there.
It is, and I found this describing the elements and how I see the elements, and
so everything in nature is made up of 5 basic elements: earth, water, fire, air, and space. Knowledge of these 5 elements allows the yogi to understand the laws of nature and to use yoga to attain greater health, power, knowledge, wisdom, and happiness. This arises out of a deep intuition of how the universe operates. Japanese traditions use a set of elements called the Godai, literally the 5 great. These 5 are earth, water, fire, wind, air, and void. These came from the Indian Vastu Shastra philosophy and Buddhist beliefs. In addition, the classical Chinese elements, Wu Qing, are also prominent in Japanese culture, especially to the influential Neo-Confucianist during the medieval Edo period. So earth represents things that were solid. Water represents things that were liquid. Fire represents things that destroy. Wind represents things that moved. Void or sky represented things not of our everyday life.
Yeah. And now how I get back to the big picture. There it is.
Let's go to the big
there
picture.
it is. It jumps from my phone back and around, so I don't find them.
It tells you, though, that humans have been thinking about this for a very long time.
Very long time, yes.
These teachings and ideas and philosophies date back, you know, more than 2,000 years. Probably
way more.
Maybe 5,000 years, or maybe longer. You know,
but they have found these stone elements that probably is the first telescope. It's like a pile of stones, and that's 6,000 years old.
Right.
Yeah.
Well, humans, I mean, understood early on that they needed to understand the sky.
Yeah.
In order to survive.
Yeah, exactly. That you stole my words from my mouth.
Yes.
Because they have to know when to harvest and when to do that, and exactly the time of
planting and
exactly
all these things, you know, when maybe to move if you were nomadic, you know.
Yeah. Sirius, for example, it was vital for Egyptians. They did know that when Sirius comes up, the Nile will flow over, so they know when to put the seas on to the ground. So the old Egyptian already uses Sirius to know when to do what, and
right.
that is called the dog star, the watchdog. So, but I had this movie I tried to show a couple of, but I didn't get it right, and now I have edited, put some music on it. I found this video for a long time ago on internet. It's not copyrighted, and the music also is uncopyrighted.
Good.
So there is on YouTube, you can find background music you can put on your videos that is not copyrighted.
Yes, you can, of course.
There is plenty of them. But let's see, I put this on. Wait, I have to pause it and move it somehow.
Harold Locke says that watching on YouTube, he says since we moved out of Africa almost 100,000 years ago, humans have been involved somehow in looking up at the stars and trying to make sense of this.
Yeah, this video is kind of visualization of that what I have been talking about to kind of meditate before I do visual. So I have my me here, but my mind is up there, way long,
way out there,
way out there. So nobody can get contact with me when I am out there. And so let's see, this is screen 4, yes. So I share this with you. It's only 1 minute long to enjoy.
I don't think we're getting any audio back
Oh,
up.
Wait. Okay, how do I get the audio?
Yeah, stop sharing for a moment.
Yeah.
And then go back into share. And before you commit to sharing, there's a little
share
check
sound,
box.
yes.
You see that? Yeah.
Yep, I saw that.
That'll get you the sound.
Yep.
Beautiful.
Oh yeah, it's really nice.
I love these kinds of visualizations.
Nice fly through. That was awesome.
Yeah.
Wow, that is awesome.
Yeah, I like it.
So that's
Beautiful.
That's my visualization when I'm doing visual astronomy or just sitting here and thinking about the universe. So I make my trips. And I was making some astrophotography. It was 2 days ago when we had a harvest moon, and Cameron showed about moon, and I got something too, but this is only with my small refractor. Can share it just a little bit, and sharing that because you can do full moon imaging. Full moon is not so bad, we think. If you get that good seeing I had when it was harvest moon,
yes,
you can't get wrong. And this still was it whole night. I can share you some pictures, then I'm finished. This is the harvest moon. And you can see that you can get good pictures. Good and good, but you can get some features, and you get some details of full moon. This is 25,000 frames. It's stacked to 15.
25,000. Okay.
Yeah, 25,000. But you can see here.
Nice.
You can get like you see craters and shadows, even if it's full moon.
Beautiful.
Super.
Nice contrast. Nice contrast.
Yeah.
Yeah. That's true, Becca. Like like you say, especially what you notice is, as we know from the lunar exploration, the moon dust is actually dark,
Yeah.
and when you, I mean, obviously, it's just once you look at it and zoom in with your, or have a wide field that your eye kind of adapts, you can actually look and you can see how dark the seas are, and
Yeah.
you can see the features in high contrast, just like what this picture shows.
Yes.
And even the different colors of the soil, there's slight different variations.
Yeah, you can see here that it's like darker, but I'm not trying to get the mineral moon yet. I like to get a really big mosaic, but not with my obstacles and whether it will take. It's a whole lifetime project if I want to make like of 9 pictures of different faces. So I have to train. I have so much to train. It's solar imaging, it's deep sky imaging, it's moon imaging, and visually. But now I have lots of space. My observatory went from 10 square meters to 67. So now I have an observatory balcony. I have my living room, and I have my bedroom, and I have this room only for observatories.
That's right. I love it.
You're surrounded by
every room is an observatory.
Astronomical world. It's very cool.
Yeah, but okay, I have to make the best of the situation and times.
Of course,
absolutely. So why shouldn't I?
Why shouldn't you? Exactly.
Yeah, exactly. And I have planned now when I have set up my living room. I have a sofa and chairs. So fast COVID allows. I have already tested everything, so I can put a camera and my telescope up and running in balcony, and I can remote control it to my TV. So I have a Facebook group already, a page. I will send the flyers around here at my area, so they can look at that web page, Facebook page, and I announce tonight or like from 6 p.m. at winter time is showtime.
Oh,
so
great!
They are welcome. They can come with their parents. They can get some coffee, and the kids can look moon, sun, some night sky on the living room. And if they want, I just put the telescope, open the window, and have a little bit smaller on the living room. I have a big window there.
Yeah.
And,
that's great.
So
too bad we can't go there and hang out with you for a little while. That would be a lot of fun.
Yeah. So I think just to see looking from inside and guided, and I can like from the beginning, like solar and only moon, and tell them like a really easy way. So because the kids do understand everything, but you have to put them on their words, like and make tests. I love to do with like I did when I was kid with the flour. We can get those big box and then 10 kilograms powder and get a really big rock and push it in there. Because I don't have so many.
Make your own crater. Yes.
I don't have so much furniture in my living room now, so it's easy to clean.
Yeah.
Just taking a Hoover and chip, chip, chip. So yeah, outreaching is just when the COVID is a little bit easier, then I will do that, because they are hanging already now on the playground. They are sitting on the bench and yelling me, "What are you looking? What are you doing?"
Right. Oh yeah.
So I would
Well,
like that.
that's a wonderful thing that you're offering for your neighborhood. I mean, it's just
Yeah,
really great. So, and
there
I'm sure
is
that people will, you'll
absolutely.
that will become a
Because
destination after
I
a
have
while.
already,
So,
because on the summertime when I was imaging moon at the daytime or solar,
yeah,
there was a walkway just under my balcony,
yeah.
and almost everyone, men, watch it and stop it and ask it, and you don't believe, but like 90% of them ask
Mhm.
it, have you seen anything weird? I said, yes, every
Yeah, I'm
time.
looking at you. No.
Yeah. Yes.
Yeah,
Men,
I think all amateur astronomers have been asked that question, or
yeah,
have you seen anything that you can't explain?
exactly.
Well, pretty much all of it. Okay, so
Everything I can see, it's
you know
something
what
I
they're
can't
getting
explain
at.
to you.
Yeah, yeah.
But I can try. Come up to a cup of coffee so I can explain.
That's right. That's right.
Yeah.
No, I mean, many people are very curious about, UAPs, UFOs, aliens,
Yeah.
so still the jury's out about some of this stuff, but I've been all my astronomy observing life, I've been
Yeah.
asked these kinds of questions. So
There is, I think, I don't remember if it was, what do you call this big thinker, and he wrote really much quotes. I think it's his, but he told that think if the thought if there are other civilization, or
yes.
are we just alone, the only civilization in universe, both are scary. If we are just alone, that's scary. If there are other civilization, that's also scary.
Well, both scenarios are
scary.
It's almost unbelievable. One of them, if we're, really truly alone in the universe,
then I would be really scared.
Ever took root. That would be an
scary.
astounding thing to know.
And we are already ruin it. If it is our only civilization, and we are going to ruin it by our actions.
Well, we'll ruin it for ourselves. That's for sure.
Yeah.
For sure.
Okay.
Thanks. Earth got pretty, destroyed a couple of times, by giant asteroid impacts and stuff like that.
Yeah.
And yet here we are, so
exactly.
It couldn't kill all the life.
Yeah, but asteroids, I can take asteroids impact, but not the light pollution and air pollution and all that stuff. Big crater is okay, but that's not our own made.
Yes.
So it's like when I at night time I had a moving box in the hall. Middle of the night, it was dark, and I went to kitchen. In the middle of the night, I kicked the box and broke my little toe.
Oh.
And the bad thing that was my own box. I couldn't complain to that's somebody else's.
Yeah, that's right.
That's right.
Well, that makes it even worse.
Yeah, that was the worst thing. Not the toe, right. But that was my own box. Yeah. Okay, thank you, Scott, to get me.
Thank you, Pekka. Thank you so much, man.
It was very, very, very pleasant time, and very good episode. And what a line Deepti have with her.
Yeah,
from India.
It's nice to have so many young people on the program today.
Yeah, and how enthusiastic they were.
Mm-hmm.
They were like burning. And
several teenagers on. It was very cool.
I have some pictures. I have some movies from La Palma Observatory when they show showed how the solar scope, it's a Swedish solar scope, it's
Okay.
0.97 meters, 97 centimeters.
Wow.
And they have, if we have time, I could share just a little bit, but it's they talk Swedish, but I could
That's okay.
I could try to translate. They have 3 instruments below, because it's like beamed down, and
Sure.
the first box, it's the tube that comes down, and the first box is the adaptive optics that he showed us earlier this week. Was it yesterday or Friday? It was the adaptive optics.
Oh, you're talking about Claude Plymate.
Yeah,
and
that's exactly what they had. And then they have this beam divider that goes for extremely H alpha. And then they have the red, and then they have green, and then they have blue. And that blue instrument is that they collect one really special beam or wavelength that is so weird. He explained the wavelength that they don't really understand what it does, because the wavelength comes up from the surface, and get up a little bit and get back in the surface, and then it gets active, like so I can find where I have that.
That would be cool to see that. Also, Harold Locke is wishing that you would zoom in on the Finland feature of the moon.
This is not this is the real okay, let's see.
Hey Scott, just so you know, I've got a really close magnification zoomed in of the moon as well.
Okay, all right, we'll have you share that.
You're ready.
This is the real how moon is for real, but if you look in the mirror, this is Finland. And there we have this small island between Sweden and Finland, and that used to be Sweden, but no longer. Crater hit it. But anyhow, yeah. But let's Simon, I can show you the video on the after party.
Yeah, why don't you give us a quick view, Simon? We'll take after that we'll take a few minute break and then come back, and we'll have some time to.
All right, there it is.
Wow.
Wow, that's good.
This is really good.
That's good.
And if you want a picture of Jupiter, that this is only one stack's worth.
Wow.
Oh, wow.
Beautiful.
Very nice.
Because I don't have my presets on this, so I didn't push it too hard, but you can obviously see some of the detail really starting to come out.
Yeah.
Oh, yeah.
That's awesome.
But yeah,
I was able.
Oh, go ahead.
I was just saying, I was able to pick out in my primitive view, I was able to pick out those 2 features, those 2 dark cyclones in the upper belt.
Oh, yeah.
And also the red spot, which was very small, actually, but still, your image really helped me pick them out. So that was pretty cool.
Oh, yeah.
Yeah, so I'm going to take out the Barlow in a second, just so it's not so bad, because the moon, even though it's like risen up to a certain height, I just know my area that when it's that low down still, I'm just going to have a shimmering atmosphere. I have to wait for it to really get up there before I know it's going to be rock solid. But if the views of Jupiter were that good, I mean, this is going to be great.
All right, so let's take a 10-minute break, and we'll be back with you guys.
Yeah, I got Saturn back in. I'll just share my screen.
My name is Dr. Jessica Gaskin, and I work in the X-ray group at NASA Marshall Space Flight Center. I'm a research astrophysicist in the group. I mainly design and build and test instruments that go into space. So my main project right now is a NASA study scientist for the LINX mission. And LINX is one concept of 4 that NASA is studying to be the follow-on to the next great observatory, which currently is WFIRST. So I get to work with an amazing group of scientists from across the country and support them in developing this concept for this large observatory. The current observatory for looking at X-rays from space is the Chandra X-ray Observatory. This observatory will be 50 times larger, 50 times more effective area than Chandra, and we'll be able to look at things like the large-scale structure in the universe and galaxy formation, and probe the very first seeds of black holes and understand how black holes form and form with their surroundings and interact with their surroundings. We're trying to make new discoveries, and so it's really unveiling a universe that's really never been seen before. The mission is in concept phase. What that means is we look at the science that we want to do. Then we have to decide how big are the optics, how many optics, what kind of instruments we need to have. And so I get to coordinate that with the community and bring it together into a concept with their help that is realistic and can eventually be built if it's selected by NASA. The bottom line is that we want to understand the origin and evolution of our universe. We want to know where we came from. I mean, at the highest level, if you could set a goal and understand how the universe formed and why we are here, that would be amazing to know that. So that's the big picture. I love working with people. I love hearing ideas that people have and trying to fold them into what the project is and what we're trying to accomplish. And so with the LINX mission project, it truly is this amazing group of individuals from across the country that I get to work with, and each and every one of them is this unique entity that brings something amazing to the table. The main piece of advice that I would give to anyone who is considering a career related to some type of science or technology path would be to get as much experience outside of the classroom as possible in any area possible. You can't choose incorrectly. Whatever you choose will end up impacting the way you do something later on. No matter what you try as many things as possible. You cannot fail. Just keep switching until you're very happy with what you're doing and until you've found something that you feel passionate enough to stay with for a long period of time. Don't stop until you're passionate about it, because then you'll work hard and you'll do well at it, no matter what it is.
Occupation STEM is a production of the IQ Learning Network, a division of Alabama Public Television. To learn more about careers in science, technology, engineering, and math, visit occupationstem.org.
Your sound is off again.
Yes, my sound's off again. We're back.
All right.
You guys can't read lips. So anyhow, yeah, I liked that last video. I thought it was very inspiring because, people that are trying to understand the very origins of our universe. I mean, that's the kind of job that, is so esoteric, and requires so much of discipline and effort by these dedicated individuals, you know, and I'm so grateful that they exist, you know. Occasionally, you know, and I know Simon gets to do this quite often because of his location. He's very close to the Jet Propulsion Laboratory, and I know that they come into the store from time to time, the scientists do, and so that it was there that I was introduced to David Steinfeld from JPL, and he took me into the Jet Propulsion Laboratory itself, and I got to see the first Martian soil simulant being melted into a brick. And so they're trying to figure out how to build habitats on the moon and Mars. And it looks like they're going to do it with microwave ovens and melting bricks and melting the surface of where our you know, moon colonists and Mars colonists will have to live. They need to do this because the dust from the moon and Mars is so fine that it'd be very easy to breathe it in and get it into your lungs. And it would be worse than, you know, coal miners' lungs, for example, you know. So there's some big challenges, not only from that, but also trying to protect our colonists from radiation, you know, and then just trying to figure out how to survive there for months or years on end. So it's fascinating though to see these people do the work that they do, and I love it that they are involved. Most of them are involved in educational outreach on some level. So very cool.
Yeah, it's I saw a documentary, or was it a competition, how the students will build a 3D printer that prints the first.
Oh yeah, that's what I was going to mention as well. Yeah, I was going to mention that too.
Right.
That's so fascinating.
Right, while the scene's still actually pretty good, I'm going to show you guys a quick feature that a lot of people ignore for some weird reason. And it's great if you've got a great big telescope to be able to see this. So I'm looking at the edge of the moon that is not actually hidden by shadow. So this is a very nice, sharp, harsh edge. But if I start to scroll upwards, you start to see the moon actually has mountains.
Oh yeah, look at that.
And they're quite well defined.
Yeah, you get to experience this during a total eclipse where you see Bailey's beads, that kind of thing, as the eclipse is coming towards the end of totality. But yeah, it's not round.
No, more often than not, where I'm looking at right now is actually where Bailey's beads actually occur.
I see.
Is that north or east?
Hold on, I've got to flip this all around because it's on the top. It's actually on the northeast.
Yeah,
we're looking at the northeast part right now because my camera and all that stuff is turning the wrong way around right now.
Yeah.
So just to show you guys the rest of the edge, because we're obviously coming towards.
That's beautiful.
Yeah.
Yeah.
So now we're going into the shadow.
Amazing.
All right.
Very responsive, very nice. Look at how nicely.
Yeah. You can
beautiful.
You can almost measure the like.
Yeah, the Chinese they just celebrated the Mid-Autumn Moon Festival, and you know, there was many celebrations. One of them I saw included dance, and it was kind of like this shadow dance where the people would merge together and they would create things like rabbits, and you know, because they see the rabbit in the moon, and you know, you would have to watch this video to experience. They can't even really describe it. It was so beautiful.
You know, the funniest thing is I didn't actually buy any mooncakes this year because usually when there's like big issues happening like this, it's never a good time to buy mooncakes. And I apologize for all the people that like eating them, but I'm just going to let you know now, they're not going to be all that great this year.
Why is that?
Well, obviously with all these things that have been happening, a lot of the materials that you would buy to make these mooncakes are not as easily obtained.
Oh,
So
I see. Right.
everything is kind of rushed, or they're using pre-packaged stuff. And the only reason why I know this is because I eat mooncakes all the time.
Yeah, I like mooncakes too.
Oh, I love mooncakes.
But I've always discovered
Never
that
seen mooncake.
if there's a
Oh,
shortage
it's good.
of something,
Becca. Mooncakes are
then-
delicious.
yeah.
What's
no,
your favorite
all
flavor?
the time.
What's your favorite flavor, Simon?
Look, I like lotus seed.
Yeah, that's
yeah,
quite. I just had
lotus
lotus seed. Yes. Yeah, lotus seed is my
I
favorite.
always get the one with the egg yolks inside of them. So
Oh, okay.
if you know how to read the tin, you can tell how many egg yolks there are inside of them. In fact, usually a lot of them have packaged on them in English if they have lotus seeds and if they have an egg yolk inside of them. And look for these lines. So you'll get a line that goes that way if you get, which means 1. If you get 2 lines, that looks like an equal sign, it means 2. And if you've got 3 lines, there's 3 egg yolks in there.
Yeah.
Yep.
They're very, Becca, mooncakes are very rich as well. So you can easily gain pounds eating these things. You know?
I have never even seen how they look like.
Yeah. Yeah.
We could have them, but
Most of them are small, you know, they're something like that, you know, and they're thick. But they have big ones, you know. They have big ones. A bigger one might be, you know, something like that. When I lived in Taiwan, they attempted to make the world's largest mooncake. It was giant. I mean, it was like, I don't know, 12 feet in diameter. And
we don't have them in Sweden.
Very extreme.
We don't have them in Sweden. Never seen them.
Put it this way, Piker. You only eat the bigger ones. That is, you cut them into quarters, and you only eat a quarter.
Yeah.
Because if you eat more than that, like a half, it's just like you can just feel it. It's like so much sugar. You get so hyperactive.
Oh yeah, just like boom.
It's like those Turkish, you know, those.
Oh yeah, the Turkish delights. Oh.
Yeah, but they are good.
Yeah, I can't.
They're
I
like
can't do too many of those
syrup.
either.
They are like doped in syrup and sugar and honey and everything, but they have nuts and so on. But they are good.
Let me see if I could show you a picture of a mooncake.
I found it.
Oh, you did? Okay.
Yeah, I found some with Chinese signs or something like that.
Yeah,
are they
let me
Chinese?
show
Or?
our audience some mooncakes. I mean, they're beautiful designs, and yeah, there's one that's cut open.
Fun story, real quick, about those mooncakes, Scott. See all the fancy designs?
Yeah.
Back in the old days, we'll call it, or ancient times, when they used to make these, they used to imprint the house names onto them, so you could tell where they came from. So everybody who produces a mooncake has a very unique design specifically to them, and only they are allowed to use it. And you could tell the quality behind it just by looking at the prints that they use.
Oh.
So traditional mooncakes in China that don't come from any specific area do not have any of this decorative look to them, and they don't have that shape. They just look like a big splodge that was just thrown together.
Yeah.
Yes. Oreo mooncakes.
Oh my God, are you serious?
Oreo mooncakes.
Hold on, go back, click on it. I want to see
Click
that
on
now.
it.
Oh
Here we go.
my God.
That's pretty bad.
Oreo mooncakes.
I have seen it all now.
Yes, you have. Yes, well, that's a celestial dessert, you know, originated in China. So
Should I show Scott the solar telescope in La Palma?
I'm sorry?
can I show you the solar telescope in La
Oh,
Palma?
absolutely, absolutely.
Yeah, I will rewind it a little bit because they are talking about them, but I pause sometimes and tell you what it's going on. Okay?
Okay.
Några stycken. Och där jag sitter just nu, det är alltså där det står SST och så ser man ett vitt L.
This is the Swedish
där nere
solar telescope.
Där marknivå sitter jag för tillfället. Och så där ser byggnaden ut.
Okay.
Ja.
Man ser ju att det är ett litet märkligt teleskop det här. Ett torn och så sitter en annan där uppe. Det fungerar ungefär som ett periskop med en lins i toppen.
And that lens is sitting only with the vacuum.
Här smäller upp en ritning också som ni ska fatta.
And you can pause its first flight 2002, and it has integrated adaptive optics and a vacuum tube, and this is the drawing how the beam is going down.
Vi ska få lite mer, va? Lins, två stora speglar.
This is the 1 meter lens. And it's only with these small things, but the vacuum is holding it. And can you see the finder scope? Here.
Det här teleskopet invigdes 2002. Det var rätt fantastiskt för att...
Let's see. I think it's... Yeah, here is the...
Wow.
Some pictures come.
Bara ett par bilder här för att vi ska få något sammanhang. Här ser vi granulation på solytan i fotosfären.
Wow.
Gasbubblor som stora som halva Sverige.
That was like the Astronomical Week, right? They had that adaptive optics session last week. It's amazing.
Magnetfältskoncentrationer. För mycket av forskning på solen handlar om magnetfält.
Oh, I love this.
Bild på en solfläck med en penumbra med väldigt små
Simon, you got pictures almost like this.
Yeah, I told Simon.
En tiondels vågsekund i blått ljus. Det är liksom en prestation. Ska vi sätta det i jämförelse med så är det att jag har varit hos
I'm trying to prove to people that you can actually get images similar to this with your telescope at home.
Kan man upplösa 0,1 vågsekunder, då kan man läsa denna syntavla nedersta radien på 3 kilometers avstånd.
He was telling the resolution of the telescope, and if you have been on the optical checking your seeing, the lowest row on this, the sign, you look and tell the letters. You can probably, with very good sign, you can see that on 5 meter and read it. And can you hear me?
Yes.
Okay, good, because it was so long. With this telescope, you can read that lowest road from 3 kilometers. From 3 kilometers. I don't know how long that is in miles, but it's like 2 miles.
Man, that's really
you can see features
incredible
that size.
Resolution.
Oh my God. You can read that the text you have in this optics sign where these letters, and the lowest probably I can read it from 1 meter, but this can with 3 kilometers.
Här ser vi spikuler, gastungor i solens...
Is that actually a picture? Oh my gosh.
Det är vackra bilder.
It almost looks like computers. That's amazing.
Utan vi vill analysera ljuset mera, dela upp det i våglängd, analysera polarisation för att ta reda på vad det är som händer där.
Okay, now we can go to next where they show the actually machinery. It's a little bit shaky, but anyhow.
Mm-hmm.
This is the backside of the scope.
Det är alltså bakänden på
This is cool.
teleskopet är ett långt rör Det är vakuumpumpat för att man inte
The
ska få
whole
problem med
tube is
varm.
in vacuum.
Solen, strålning har ju värmer ju upp saker och det vill man inte att ens värdefulla eller det vill man inte ska förstöra.
And this is just to eliminate turbulence.
Ni ser att det lyser lite vitt här.
And you have this box is the adaptive optics.
Som jag har där nere. Där inne gömmer sig den adaptiva optiken, den här spegeln som ändrar form 1000 gånger i sekunden.
Yeah.
Gör bilden riktigt skarp. Ska vi se.
And there is some instrument.
Det ser en väldig massa pinaler, svarta lådor.
For those of you that are watching, last Friday we had the Astronomical League live program that we broadcast, and Claude Plymate, who worked at the Mass Solar Observatory in Tucson, and then he worked at Big Bear Solar Observatory, where they had a very advanced active optics package. I'm sure these guys have something very similar. But to get that kind of resolution takes, a very advanced kind of active optics system, and Claude was kind enough to really explain that in great detail.
Yeah, this black box is the new instrument they have, and it reads that blue spectra that was on 10,380 angstroms.
Jeez.
And he tells about it, but it's very, very difficult for me to explain. But that's the weird blue spectrum that they are looking for. Let's see if I can find something more interesting in this. No, we can go to next, and where they show the adaptive optics. This is the computer that Clyde showed us.
Oh, wow.
So this is only one sunspot with all those sensors that Clyde showed us. But we can go upside.
Yeah.
It shows all the scopes, but especially is that they have like 15 scopes there, but this is something I wanted to show you. This is only a mirror, and that will be demolated. It's a Danish, but that one there, the world's biggest optical telescope. It's 10.4 meters.
Holy smokes! Yeah.
And it's like comparably with the Hawaiian telescope.
Yeah.
But they are planning to build here somewhere. World's biggest. It's going to be 40 meters in diameter.
Whoa.
Yeah.
Where is this, Pekka?
This is in La Palma.
La Palma, yeah.
Canarian Island. They exactly the island they had a volcano right now, but it's on other side of the island.
Wow!
So they have a volcano right now, and there you can see horizon and the sea and clouds. So that's the presentation.
That was awesome, Pekka. Very cool.
Yeah.
And then
Thanks.
Simon. And that's showing the cutting edge. I mean,
yeah.
And then Simon, you were saying that earlier that basically you're trying to achieve that level with amateur gear, right?
Yes.
That's really cool. I love that.
I have to ask Simon if you have heard about the green lightning when sun goes down, sets.
Wait,
green flash.
Yeah, green flash.
No, I haven't heard that before.
Neither do I, but
Seriously,
he was
in California,
talking about.
you've never seen the sunset and seen the green flash?
To be totally honest, I don't actually watch the sunset all that often.
Okay. All right, Simon. New assignment here, because you're in California and you got a great chance to see the green flash, is to watch the sun, on a nice clear day. It's got to be really clear all the way down to the horizon. And as the sun gets down to the last part of it, you will see a brilliant green flash from the top of the sun.
Really?
Yes. And you can also, I was at David Levy's residence, and he showed me the green flash from the moon. Okay.
Wow.
Yeah, from the
Is that
setting moon.
similar?
It's similar. Yeah, it's beautiful too.
I have to see, first of all, I have to see this horizon. I haven't seen horizon in 6 years.
Ah. Mm-hmm.
That's true. And how I can get that is to take a ferry back and forth to Finland. It's an open sea, and there it will be sunset also, if it's clear. So I have to book like last minute journey so I can see that it's clear. So I will take my camera with me and look after those. But is it depending in the latitude you are living on?
That I don't know. I've seen from California, I've seen the green flash many, many times. Definitely have seen the green flash in other areas as well. But you can see there's lots of photographs of it.
Is this like an optical thing that happens?
It's an optical thing, refraction through the atmosphere. Mm-hmm. So you can see, this is European Space Organization, some recording of that.
Wonderful. I never even heard before. He told that tourists are like hunting after that.
Oh, sure.
I think it must be something to do with the latitude.
Now, okay, so here's the moon and the green flash from the moon.
Wow.
Apparently, David Levy had seen it so many times from his home that he just told me, he said, "You want to see something that you've never seen before?" And I said, "Okay." And so he says, "Watch the moon." And he just knows it's going to happen. And he's still working on his telescope and stuff and getting his Dobsonian ready and everything. And he just lets me watch it. Like it's commonplace to him,
Yeah.
I've never seen it any other time. Okay. But we definitely saw it that night. It was really cool.
Is it like just a few seconds or
Yes. Yes,
okay.
It is.
So you have to be on your watch.
You have to be on the watch. You're watching it go down below the horizon. And yes.
Oh my.
Sorry, it's going to be the last moments, because once it goes past the meridian, I will not do a flip with this C14.
Probably not a good idea. Yeah.
And seeing is pretty damn good right now.
It is pretty good.
Tiny bit of drift right now.
Because like right now, 5 milliseconds.
Say that again, Scott.
Your exposures are 5 milliseconds.
Oh yeah, I've dropped this down a little bit more. It's just to help with the contrast. So if I was to bump this back up, obviously it gets a little
there
brighter.
You go. That actually looks better.
Oh yeah, for capturing, I try not to go too harsh because the noise is just too severe.
Yeah.
I'll mess with the contrast a bit so you guys can see it a bit better.
Oh, look at that. Oh yeah.
There we go.
That's cool.
And the only reason why it's drifting so much is because I didn't actually go to it, because I don't know if you've ever used a scope this big before, but the Go 2 isn't as deadly accurate as I would want it to be.
Yeah.
That is
Isn't it nice?
unbelievable. And the red spot already has gone.
Oh yeah, the red spot has gone completely, but the two blobs that we saw that were originally here and here are now up there.
Yeah, it rotates really fast.
It does. It's like what, every 9 hours? Is that right?
You know what? I keep hearing different reports. Some people say it's 10.5. Some people say it's 9.5.
Let's find out.
I heard 10.4. That is unbelievable. Is it that Celestron's 14-inch?
Yeah.
It's a 1980s C14.
That really orange.
Yeah,
color.
it's the orange one with the grey ribbing on the back of it. So that's how you know it's a pre-Hal-Bopp scope.
My first Celestron was a little bit kind of odd. It was an 8-inch, really orange, but it had a wooden tripod, equatorial tripod.
So I could tell you a story about those scopes, and I think Scott knows this story as well. So during what was it, the comet Hal-Bopp, when the comet was coming around, Celestron rushed out a whole load of scopes, and I remember there was an order in Japan that they placed, and it was in the thousands. And then towards the end of the production run, and you know the hype was dying down, they turned around and cancelled the order.
Oh my God.
So the market was then suddenly flooded with all of these 8-inch scopes, which I think
8-inch. Okay.
which I think they were called the Nexstar 8i, I believe.
Okay.
With wooden tripod.
And if they were bright luminous orange, they
Yeah,
were
they
the
were.
scopes that you don't want.
Okay, I bought mine 92, and it was already used, and the focusing knob had plonk. It was like you felt when you focused, it was like not straight. And I wrote a letter to Celestron that can I just take a hammer and bang it or some kind, and they just wrote back that no, if the focusing is working, don't do anything.
Yeah, some of the focusers, I think the 1970s focusers on those, on the C11 and the C14 were probably the best ones.
Yeah, it was a steel. The focus knob was all steel.
Yeah.
It was now rubbery.
No. Yeah, it was all steel. It has this weird little clock dial on it. And to be totally honest, the bearings that they used back then were so incredibly stiff. I mean, most of the focusers that I've seen from this era, they all have flat spots on them. And the reason why is because that is actually where the focus actually is.
Yeah.
So you could tell when you're close to focus because you'll hit this flat spot all the time.
No, it's because they left it at focus.
Yeah, for so long.
Yeah.
Yeah.
This is an awesome.
It's beautiful.
Image.
I love this.
Beautiful. This is really fantastic. And it shows, you know, the optics, if they're made well, you know, and they last. And it's, you know, and now you're applying today's technology, Simon. I mean,
look at all the colors you can see.
You could almost make a TV channel, cable TV channel that broadcasts.
The Jupiter channel. It's just all Jupiter all the time.
No, from everywhere on Earth. Just like take your location, who is live broadcasting.
Yes.
From Taiwan, USA, Australia, Sweden, Finland, and pick your what you want to look, and somebody is live streaming.
Was there any moons close by?
It's
no,
very possible to do.
I was hoping there was a moon close by.
Hey guys, I gotta jump out. So
Cameron, you take care, man.
yeah, have a good one. This is awesome. I love it.
Good.
Very good show. Good
Thank
seeing
you,
you guys.
Cameron.
Yeah,
Thank
good
you.
seeing you, Simon, Becca, and thanks, Scott. Talk to you all later. Have a good one. Cheers,
Yeah.
guys.
Thanks, Cameron.
Deepti and everybody, if you're watching, thank you. Thank you again for all of this. So it's great. Well, gentlemen, I
call
really
it a night.
appreciate you hanging in there and sharing your thoughts and beautiful images and all of that. It's really cool. Want to thank the Nepal Astronomical Society, NASO, for participating in the way that they have and sharing their experiences and their knowledge. It was wonderful. Deepti's suggestion to pick the theme of Stardust, I thought was amazing and great. It was so fun looking at special quotes about, from Carl Sagan, and I found one from Deepak Chopra, about Stardust, and it was quite profound actually, and so it was, it's cool, and thinking about our connection with the stars, using that as kind of a lens of perspective, of how our, the living part of us, that are made up from the elements, are hardwired to the universe. I mean, it's just a lot of people don't think in those terms, but that is the truth of the matter. And so I that's the reason why I put in the original, the placeholder. So if you kind of came in late on the program, I always like to put in a quote. And this is from Carl Sagan: "Even through your hardest days, remember we're all made of stardust." I think that's just really very
it
nice.
calms. It calms you down.
Yes, it does.
Yeah,
It
I do have a small belief that for the most of people, they think if they are starting to look about the stars and so on, that they have to study to understand. They have to read a lot. They have to have the real dedicated knowledge and so on. So they have some that they are fair of to let the stardust come in. I don't know, but
well, it's just, this is, science trying to understand our origins,
yeah,
what we're made of, what is the interrelationship,
exactly,
between all these things. And so
true.
Well, it seems very poetic, and kind of maybe if you say, yeah, we're all made of stardust, and people that might, seem kind of tongue in cheek, so to speak.
Yeah. People don't.
It's how that is the truth of it. That's what we have become to understand. Now,
yeah.
Where religion and philosophy would enter into this, we still don't know how it all comes about, or why it has all come about.
I usually say to people, my nearest people, that I show their ring or ear hang or necklace, the gold. That did you know that that gold is from a supernova? How did it get to the Earth then?
Yeah, how did you?
Yeah,
how do you know that?
Yeah, okay. Then I said, where came the Earth? So I usually say that all the heavy metal we have in Earth, all that stuff is beginning from the supernova, and it's 0.5 second in that extremely heat and pressure when supernova explodes. There, all the heavy metals are produced. But it's small stuff.
Yes.
And then they collect.
Yep.
So they are.
It's really, it is amazing, the whole process of constant creation and destruction, so it's just, we get to take the ride because we're conscious of it, and we have made some pretty good tools to go check it out, so.
I like to make a hidden camera when I go into a jewelry store, and the customers ask me, okay, how can I help you? I said, I want some 10 grams of supernova stuff. Supernova resistant.
That's when they call the manager.
Yeah, hey.
Get this guy out of here.
All right, Scott. Yeah. So let's call an end to this.
Simon, thank you, man. Thank you.
Thank you, Simon.
For dragging out to 14. Becca, thank you so much.
It was really fun. It was really fun.
It was.
Yeah.
And again, thanks all of you in the audience for watching. And we'll be back Saturday with the next Global Star Party with the Royal Astronomical Society of Canada, the Montreal Centre, and the Royal Astronomical Society of New Zealand, where they will have what they're calling the 45-degree star party, 45 degrees north, 45 degrees south, held simultaneously in daytime and nighttime. So it's going to be pretty cool.
Is it now Saturday? 25th?
Yeah, this coming up Saturday. It's 7 p.m. Central, 8 Eastern, 1 p.m. New Zealand time the next day. Okay, so
at the exactly same day, we have a whole Swedish Astronomical Society will hold a whole day event. It's like the star party for whole country, and it's virtual.
Very cool. Very
so
cool.
Good. I have several screens I can.
It's nice.
It's whole
nice.
day.
It's wonderful, all the things that we have access to these days. Also, we have 7 months of science with Caitlin Ahrens this week. We've got lots of things coming up. And so stay tuned, keep watching our calendar, and we'll see you as early as tomorrow. So take care. And as my good friend Jack Horkheimer would always say, keep looking up. Thanks, Simon. Thanks, Becca.
Thanks.
Good night.
Good night.